Hello, Stephen. Connecting to the audio. Connecting to the audio. Why it is connecting to the audio?
Theory already చెప్పేసాను వాళ్ళకి ఎస్టిమేషన్ ఆఫ్ సోడియం బై యూజింగ్ ఫ్లేమ్ ఫోటోమీటర్ అదే ఇప్పుడు ల్యాబ్ అదే ఇంకొకసారి మళ్ళీ ల్యాబొరేటరీ వైజ్ గా చెప్తాను అంతే అంటే అంటే అని అలా వదిలేదు చాలా రోజుల నుంచి చెప్తున్నారు చెప్తా 2 మొక్కల కోసం వెనక్కి చూసుకుంటే రంగు కోసం రంగు ఇంటికి చెప్పేసి వచ్చేస్తాను పట్టుకుంటే తిండి వల్ల ఏమో
Hello, Stephen. Can you hear me? Yes.
Morning,
yeah. Okay, yeah. So how are you? Tell me.
I'm fine.
Nice to see you again.
You too.
And how about the kids? They are okay?
Yeah, I just handed them in at the kindergarten.
Oh, okay, that's good. Yeah, that's good. Yeah. So now, could you please check whether you can share the PPT files nicely or not. Just please open the PPT file first and try to share it.
Sure, no problem.
Let's see whether it is. Oh yeah, it's working. Yeah.
We normally use Zoom at my
yes,
university, so it's not a problem. It would be more problematic if it was Teams.
Yeah. That's why I'm just wondering whether it will work very nicely or not.
I think it will work.
Yeah. It's possible. Okay, now you can stop the screen sharing. Yeah, you can move out. Yeah.
So how's the academic life in India?
Yeah, it is a different kind of life rather than the research life. It is completely different, and it is completely different. But I am missing the research. That's the thing.
You're missing the research.
Yeah, so active research. I'm talking about active research. So we need some like I need to apply for some funding first, and then it will come, and it will be delayed for another like 6-7 months, and then you need to establish the lab, and it is really very time consuming, and by that time maybe you will forget your project. So that's the thing. But anyway, so we have all those projects, so that need to be concluded very soon. I am in touch with those Osaka team, and Masatoshi already finished that. So maybe by the end of the December we can get something from the Osaka. So yes, I am also doing like that. I'm also keep all my fingers crossed, not only two. I just keep all the fingers crossed and hoping for the best. But I think that this time, like TRMC data may not be so much exciting. So that's why maybe we can just send it to chemical science first. I was initially thought about the JAX, but I think that the data looks like not so convincing. But I will contact Sessler first. And then we will decide what to do. But with Francis D'Souza, we want to make it a big paper. That is for sure, and we'll discuss about that later.
Sure.
Yeah, that's the thing.
So how large is the university?
It is good. It is good. I mean, if you compare to other universities like IITs, so those are very big.
Okay.
But this is like average. Yeah.
You are not missing Shanghai at all?
No, but I just meet. I mean, the foods are very good and very cheap. So that is the only positive side of that. It is very, very cheap and really very tasty foods, very tasty. And weather is also very good, and it is not so hot and not so cold. Just only for 3 months it is hot. Otherwise it is really very cool. And Masatoshi will join. Masatoshi will join your lecture. He already emailed you, right? He will join.
No problem.
Yeah.
But I mean, a big part of my talk is the historical work of TTF Calyx Paroles. So
yeah, that's the thing. That's the thing we need to know, and we already know. I mean, but many other people don't know that. But that is the interesting thing. Basically, that makes us friends. So that is the importance of that molecule that can bind many chemical friends.
Yeah.
Who? All right.
How's the weather in India?
Sorry?
How's the weather in India?
Bangalore is a very fantastic place. I mean, the average temperature is around 25 degrees Celsius throughout the year. It is very good, comfortable, and not like your place. Your place is like cold. So
maybe, I mean, this is outside my house, and you can see that it's still dark outside, very cloudy, and just a few degrees.
I know the temperature is 4 degrees. 4 degrees today. I already noticed that.
But it's always just above freezing, so we almost never get any snow. Just cold and rainy.
Oh my God! Oh. Just cold and rainy is not good. Because kids cannot enjoy that.
No one can. No.
Yeah. That's true.
So, welcome, Professor Ramakrishna Rao Garu.
Yeah. Hello, sir. How are you?
Welcome, Professor Stephen, sir.
Thank you.
Okay. I will introduce Professor Ramakrishna Rao Garu. He is one of the senior professor in the GITAM University. So, sir is going to act as the chair of the session.
Okay.
Sure.
Thank you.
Yeah. So, sir is Stephen. Sir will he is a resource person. He will deliver the lecture. And I will introduce Dr. Atanu Jana. Dr. Atanu Jana, say hi.
Yes, I'm there.
Yeah. But you know you are there. But others, okay, say hi whenever I say. Dr. Atanu Jana, sir is the co-convener of the program. And then Dr. Nagarazu.
Hi, sir. Good afternoon.
Dr. Nagarazu,
Yeah, good
he is the
afternoon.
co-coordinator. He is the coordinator of the program. I think
Yeah.
Dr. Professor Ishida also joined the program. It seems to be.
Yes.
Yeah.
Oh, hi. Sorry for that.
Oh, okay.
Oh.
Masatoshi, I can
Hi.
just say hi, hello to Stephen.
Hi.
I'm Masatoshi.
Oh,
Yeah, nice
hi.
to meet you. I just back to here.
Okay, very good. Nice to see you again here, Masatoshi. I appreciate that. I hope that Stephen will share some very interesting recent results.
Yeah, I hope. I'm looking for that.
Yeah. All right, so we can start now because it is already 1 p.m.
Yeah.
No. 3 more minutes is left over. Let's
I
wait.
think it is 3 more minutes. I think it is already 1 p.m. in my device, all my device.
Sir, you are from Japan, sir. You are advanced.
Yes. Japan is very advanced, and
That's why I'm saying that as you are
India,
from Japan,
India
you are
is
running.
India is late.
Slowly.
India is late, but I want to GITAM like faster than Japan.
Okay.
So that's why just in my device it is showing that it is already 1 p.m. So that's the thing.
And moreover, pre-lunch session we have extended up to 12:20. We have to give a little bit time to the participants also to have their lunch. Sir, Ramakrishna sir and Atanu sir. Okay, we are having almost 17 poster presentations.
Okay.
We can give maximum 4 minutes for presentation, 1 minute for discussion.
Okay.
Otherwise, by 3:45 we cannot finish.
It's impossible.
Yeah. By 3:45 we have to go for the validity.
Right.
So 4 minutes presentation, 1 minute only for discussion.
Okay.
Yeah, now it is the time.
Yeah.
Okay. Good afternoon to one and all. This is Professor Venkatnath, the convener of the program. I welcome all the delegates, the resource persons, the chair of the session, my colleagues and delegates to the third day and last session of International E-Conference on Advances in Science and Technology for Betterment of Health, Environment and Energy. This session will be for 3 hours, 1 p.m. to 4 p.m. Indian Standard Time. So today morning we had one talk by Dr. Moiety from National Forensic Science University, Gandhinagar, and one more interesting talk now we have from Dr. Stefan of Denmark. As I told, Dr. Stefan is going to be the resource person, and the program afternoon session will be chaired by Professor Ramakrishna, a senior professor from GITAM Institute of Science, Visakhapatnam. And this session is also will be coordinated by Dr. Atanu Jana, associate professor and coordinator and co-convener of this program, GITAM School of Science, Bengaluru. And today in the 6th session, we have 1 p.m. to 2 p.m. there will be invited talk. Of course, Dr. Stephen will be introduced by our own coordinator, Dr. Atanu, followed by 2 to 3:45 p.m. will be the poster presentation. The poster presentation, as we discussed, good number of the poster presentations are there. So we are going to restrict each presentation for 4 minutes, followed by maximum 1 minute discussion. It is followed by a validatory session for 15 minutes. So this is about the list of poster presentations, around 17. That's why we can allocate 4 minutes per presentation and 1 minute for the discussion. This is followed by validatory. So in this validatory, that session will be taken care by Dr. K. Nagaraju, one of the coordinator, and we'll be having messages by Subramanyam Garu, the Dean of Science, and a message by Professor A. Ramarao, Principal GITAM, Hyderabad, and vote of thanks by Ratnamala, and at the end we'll be having the Indian national anthem. So this is about the information. The list of presentations were already circulated to all the presenters and including the chair of the session. Now I hand over the session to the coordinator, Dr. Atanu Jana, who will be formally inviting both chair and resource person. Now the session over to Dr. Atanu Jana.
Okay, thank you very much. And hello everyone once again, and good afternoon and welcome back after the lunch break. Okay, so now let's start this final session of this 3 days e-conference or desktop conference. And I hope that everyone enjoyed for the last 3 days and I mean like 5 sessions. And now we are in the final session, and we have a wonderful material chemist with us from the Denmark, the University of Denmark, and I mean around 20 posters. And meanwhile, the session chair is Dr. Ramakrishna Rao, Department of Chemistry, GITAM University. And please join me to welcome him. Welcome, Dr. Rao. And
Yeah.
this is the virtual welcome to the GITAM University.
Thank you. Thank you very much.
Yes. So now join me to welcome Dr. Stephen Baring from University of Southern Denmark. And it's my immense pleasure to introduce my chemical friend, Stephen. And we never met, we just met virtually. And he will talk about a great molecule today that is called like TTF Calyx Parole molecule, which bring us together in the world of TTF chemistry. At present, he is one of the pioneering TTF chemists I know so far, who work actively in this molecule, and he's exploring the potential applications of the TTF-based systems. And now I wish to give a very brief introduction about him and I mean, what he did for the last few years. So he received his PhD in supramolecular chemistry from the University of Southern Denmark in 2013 under the guidance of Professor Kent Nielsen and Jan Oscar Jepsen. And this university is basically the origin of that molecule, that TTF Calyx Parole molecule. So while working on that molecular sensor incorporating the TTF Calyx Parole, he joined the research group of Professor Jonathan Sessler, University of Texas at Austin, USA, for a research stay during 2011 to 12. And you may know that Sessler is one of the pioneering Calyx Parole and expanded porphyrin chemists, having the H index around 100. Following the awards of the PhD, he worked at the Danish Technical Institute. And during this period, he focused on supporting the research and development efforts for the Danish industry, with a particular emphasis on oil and gas. From 2016 to 18, Dr. Baring was awarded the Danish Independent Research Scholarship to work in the group of Professor Jepsen, Sessler, and Gouldy. Again, Professor Gouldy is a famous photophysicist in the present era. And now, Stephen mainly focused on the organic photovoltaic based materials based on the TTF. In 2018, he was appointed as the assistant professor in the University of Southern Denmark. So that is all about Stephen. And now I want to give a very brief introduction of the TTF Calyx Parole, because I can't stop myself to introduce this molecule to you guys before Stephen. So sorry for that, Stephen.
That's okay.
Yeah, we consider this molecule as the wonder molecule because the reason is very simple. It produced one science, one nature chemistry, PNS, account of chemical research, around 10 JACs, 3 Angamanthysemi, 2 chemical reviews, and 1 chemical society reviews. And the total number of approximately 40 high impact journals are reported so far. And I am personally a big fan of this magical molecule as well. It was first reported in 2003 by John Becher. And but still now many things can be done with this molecule. Now let's see what kind of new things and new information Dr. Baring is going to share with us in this afternoon. And I'm expecting some materials application and sensing property from him. And so please join me to invite him for the talk on this molecule. Dr. Stephen, please go ahead now, and the audience is yours. Please go ahead.
Thank you, Atanu, and thank you for your kind introduction.
Yeah.
It is a funny thing that we haven't met in person yet, but we
Yes,
still have
yes.
a strong
Always we met
collaboration.
virtually. Yeah. But we share many interesting papers.
Exactly, and once COVID-19 has passed, hopefully we'll get the chance to
yes,
meet.
for physical meeting, yeah.
But we definitely share the passion for TTF chemistry and applied science.
Yes, of course, yeah.
Yeah. So as you can see from my topic, Atanu has boosted the title to the wonder molecule for modern day applied supramolecular chemistry. That might be a lot. So this molecule, I don't know if all of you know about TTF chemistry, tetrathiophobiline, but this tetrathiophobiline Calyx Parole molecule was first originated some 20 years ago. And since then, there's been a lot of papers, and as you can see from the graphics, which is the cover artwork for a review we did, there are different applications. So we have the electroactive moiety that can be introduced in electron transfer in artificial photosynthesis. Then we have the possibility of complexing ion pairs, so it's a receptor there. And we can also modify the compound to make it allosteric. So we were able to introduce a moiety that would pre-organize it so it would interact in a different way. And then most of the talk today will be about the explosive detection, as you can see on the lower left part of the screen. But just to begin with, I would like to also introduce where I come from. And I think Atanu mentioned it. I live in a small country in Northern Europe named Denmark. It's a very old country, and we have a king and queen. We only have 5.8 million people, so that might not be a lot when coming from India. And in terms of size, it's also a very small country. So I'm situated down here in the middle on this small island of Fyn in a city called Odense. And the main city is Copenhagen. Some of you might have heard about that. It's a very popular tourist attraction. Denmark is very famous for its mentality. So we have a term called hygge, which is a mental state of mind where we are very relaxed and enjoying ourselves. So that is very famous. At least in the US, they are very interested in how we have this type of mentality that we can just relax and enjoy ourselves. Among other things, we're also famous for the Danish fairy tale writer Hans Christian Andersen, if you know him. And he was also the author of The Little Mermaid, which we have a statue in Copenhagen that is also very, very popular to get your pictures taken with this one. Then we have some very beautiful scenery, and here is a picture of the beaches on the western coast towards England. And we also have a lot of medieval castles. This is Kronborg, which is also famous from the Shakespeare play called Hamlet. You all know that something is rotten in the state of Denmark. And then finally, we also have my university, which is this one. So my university is only 50 years old, and it has a modern feel to it. They made this concrete-like structures where we're working in. So in my research group, we're mainly focused on organic synthesis, but we have a focus on electroactive materials where we have applications in mind, such as supermolecular chemistry and functional materials, and we're working with organic photovoltaics. And some of the structures you can see around is collaborative work with Dr. Atanu. The electroactive moiety is the tetrathiafulvalene, which you can see in the middle of the screen. Now, this molecule was first synthesized back in 1926 by Hertley and Smiles, where they made this dibenzo version of it. But it wasn't until some 50 years later that Fred Rudel synthesized the core TTF unit. And then in the 1970s, the TTF molecule became world famous because it was reported as being the first organic superconductor, meaning that it had zero resistance at low temperature. And we were able to make this with a strong electron acceptor, such as the TCNQ unit. The electron donor properties of the TTF arise from the fact that you can oxidize it, and when you remove electrons, the 1,3-dithiol moieties become aromatic according to the Hügel theory. And this process is a stepwise and reversible process where you can reach the TTF radical cation, having one of the moieties being aromatic, and then the dication where both ring structures are aromatic. The potential is quite low, and we're able to modify the oxidation potentials by changing the peripheral positions of the TTFs. Then in 1989, Yamashita and colleagues synthesized this extended TTF where the central fulvene bond was extended across this anthraquinone moiety. And by extending it here, there's also an extra benefit upon oxidation that the central ring becomes aromatic. Therefore, extending the TTF can also lead to lower electron oxidation potentials. And then, most importantly for my talk, my former supervisor, Jan Jefferson, reported in 1999 the synthesis of this monopolar TTF building block. This was originally thought of because it would rule out the stereo isomery, where typically the TTF unit had cis-trans isomery. And by removing part of the TTF and introducing the parole, we were able to avoid any type of stereochemistry. But of course, introducing the parole moiety opened up for a vast potential of different designs. And just to briefly introduce you to the Calyx Parole, this was originally reported by Bayer in the 19th century when he accidentally condensed parole with acetone in the presence of hydrochloric acid. And he reported that a white compound was precipitated out of the reaction. But then, as Atanu mentioned, Jonathan Sessler and Phil Gale reported many years later, more than a century later, that this compound was actually able to be a host for anions. And you can see here that there's several degrees of freedom with these single bonds where the parole units can rotate, and they describe these four discrete conformations as being the stabilized version. So we have mainly the cone conformation where all the parole NH protons are pointing in the same direction. And then we have the 1,3 alternate conformation where they are pairwise facing the same direction. And it's the 1,3 alternate conformation that is the most stable one in solution. But they discovered that upon adding anions to the solution of Calyx Parole, they were able to complex anions. And here you can see a crystal structure of the pristine Calyx Parole in the 1,3 alternate conformation, and when it binds chloride is in the cone conformation, where all of the NH protons are pointing in the same direction. So just to show you a little bit of the synthesis, because while Jan reported it in 1999, there has been some improvement since, and we're able to make these compounds in more than 10 gram scale, and we can settle with only having to make 3 chromatographic purification steps. So a lot of it is just precipitating and isolating, and you can see that we have the first step, which is a 1,3 dipolar cycle addition, where we have the dipole in this unit here, and then we can precipitate out this diester compound. Then we do a reduction to generate the primary alcohols, substitution to get the bromide, and then using sodium tossyl amide, we can form this ring close structure around the nitrogen. And from the dibromide, which is also crystallized, we can generate the part of the building block, which we call the ketone, in 3 steps with only 1 purification step at the final stage, which is nice. And we get this compound here in around 10 gram scale. Then there's a quite direct synthesis to making the counterpart, which in this case is the thiopyroles. And this can be made in 2 steps with only 1 column. Then coupling them together using triethyl phosphide, we can get the monopyrrole TTF in around 70% yield, detosylation in high yield as well, and then we have this functional molecule that we can apply in Parole chemistry. And my PhD supervisor back in 2004 reported the synthesis of this tetracris tetradiafulvalene Calyx Parole, where he used trifluoroacetic acid as the catalyst, and were able to generate the compound in 18% yield. For Parole chemistry, this is not necessarily a high yield, but with the TTF, we are facing some problems. We also get the Calyx 5 Parole as a minor product as well. Yeah. So this molecule was originally thought of as being able to introduce a modulator, a transducer. So we already knew that the Calyx Parole could bind anions, but by introducing the peripheral TTF groups, we were expecting it to be able to measure the change in oxidation potential upon binding anions, and there we would have a tool to estimate the level of binding. But this wasn't the interesting thing that was discovered with this molecule. It was actually that in the 1,3 alternate conformation, as you can see here, it had 2 tweezer-like cavities with the electron-rich TTF arms, and then it had the NH protons of the opposite TTF paroles pointing into this cavity. And it was discovered that nitroaromatic explosives such as TNT and its derivative 1,3,5-trinitrobenzene was able to bind in a 2-to-1 fashion. So you can see here that we have these 2 T and B molecules situated within the tweezer cavities, and we also have hydrogen bonding interactions between the NH protons and the oxygens of the nitro group. So this type of complex is stabilized by 2 hydrogen bonding interactions, as well as the pi electron donor acceptor charge transfer interactions between the electron-rich TTF arms and the electron deficient benzene ring. And this can be seen here in colorimetric response, where we have the yellow compound for the Calyx Parole, and then TNB, which is colorless, upon addition, turns the solution green. And you can see this, this band here, which is quite strong from the charge transfer. And this is estimated to have a binding affinity of 10 to the 5th. So this is quite strong. This was, of course, very interesting because being able to detect or bind explosives is of interest to everyone. However, as it was originally thought of, it would bind anions, and you can see that if we introduce chloride in the form of tetrabutyl ammonium chloride, then we would impair this complexation with explosives, and we would actually just get this anion binding. This you can see that when we have this solution with T and B, the green solution, and we add in 5 equivalents of tetrabutyl ammonium chloride, then the solution turns yellow again, and you can see that there's effectively no CT band present. So this is because the complexation constant with the TBA chloride is higher than the overall complexation with the T and B molecule with the explosive. This was also shown that if we wash the chloroform solution, we could effectively remove the salt and restore the CT band. So this showed that it had potential in binding explosives, but we are also challenged by the fact that it's very strongly binding anions, and overall in the environment anions are present, and we want to be able to remove that interaction. Another interesting thing about this molecule that I would just briefly describe is that it's able to bind spherical electron deficient molecules such as the fullerenes. And as you can see, just mixing together the TTF Calyx Parole with a fullerene doesn't really introduce a strong complexation. So you can see that in this absorption here. So we have this at 748 nanometers, which is just mixing together the Calyx Parole with half an equivalent of C60, and we see a weak CT interaction. But if we introduce tetrabutyl ammonium chloride to this solution, then the CT band is increased quite dramatically because this induces the cone conformation, and the complexation is much more pronounced with the fullerene. These cartoons are of course based on crystal structures, so it clearly shows that the fullerene is situated within the cavity of the TTFs. So this is just an example that this molecule having 2 binding sites in the 1,3 alternate conformation and being able to introduce a different type of conformation when introducing anions, and then it can bind fullerenes, makes it quite complex. And to me, this is much more related to the natural biology, where we have enzymes and we're able to have allosteric modulation, and we can really play around with this molecule, how we introduce different conformations and complexation types. So I find this really interesting. Going back to the complexation with the nitroaromatic explosives such as T and B, we have also been able to derive the stepwise binding, and this is interesting because the TTF Calyx Parole is flexible and dynamic, and it doesn't exactly retain the 1,3 alternate conformation, but it has some flexibility to it. But upon binding the first T and B molecule, then it pre-organizes the second binding site. And when the first T and B molecule is complex by CT interactions, then it draws away electrons from the NH side. This makes the vacant NH protons more acidic, and therefore they will be better in forming hydrogen bonding interactions. At the same time, we have these hydrogen bondings here, and they again affect the electronics of the vacant TTF unit, making this a better electron donor. So overall, binding the first TNB actually makes the second binding much stronger, and you can see this is affected in the binding constants, where the second binding is actually quite a lot higher. And as I explained, this is due to both the CT interactions and hydrogen bonding that are inducing a stronger binding interactions in the opposite side. So this is very interesting, and it would be nice to be able to control which of the interactions are favored. And I think at this point I started doing research with this molecule, and we really wanted to be able to show a strong complexation with explosives, but without having interactions with anions. So we had two approaches that we could do. We could either improve the complexation with the explosive without improving the complexation with anions, or we could try to introduce some conformational restraint where it was unable to form the cone conformation. So I showed this by synthetically fusing together the two opposite TTF units, and this has been attempted in a lot of different experiments that has so far not been reported because they've been unsuccessful. One of the reasons being that most type of synthetic chemistry also introduces anions, and therefore it's difficult to avoid the Calyx Parole being in the cone conformation. But the first examples of improving complexation was actually done by increasing the pi surface, introducing thiophenes and benzenes on the peripheral TTFs, and this increased the binding constants to explosives, as I will show you shortly. Another way of modifying the interactions was to actually remove two of the Parole units and then introducing thiophenes instead. So this would make only one binding site for the explosive, whereas the hydrogen bonding interactions in the cone conformation would also be severely weakened. But not having the TTF units on the opposite side with the Parole actually makes it a much less of a hydrogen bond donor, and this was reflected that a binding constant between TNB and this Calyx Parole only had a Ka of 4, and it didn't really bind anions. So this type of experiment actually resulted in a more favorable binding of explosives, but with a much less affinity overall. So it could not be applied within sensing explosives. Now going back to the pi extended versions, then the native thiopropyl compound 1 actually has the highest, the lowest oxidation potential compared to 2 and 3, meaning that they are actually better electron donors. So one should, in essence, be better at interacting with the TNB molecule based on the CT interaction. But as you can see from the graphics, then both 2 and 3 have higher binding constants, and 2 is binding much more strongly than 1, and 3 is also, as I tried to show on this schematic, where you can see that we can't really see the binding of 1 because it's so weak compared to the others. It's 10 to the 3rd, whereas 2 is 10 to the 6th. This was originally explained by having a better pi-pi interactions, because the pi surface of these extended compounds may be able to better interact. In my perspective, it's more a matter of making some compounds that are less soluble and taking advantage of the solvophobic effects. Then these two molecules are actually much better at binding TNB. moving on, during my PhD, I investigated the effects of solvent because these compounds were originally thought of as only being soluble in chlorinated solvents. So not much has been done in experimenting with them. But you can see here that by changing solvents to a very soluble dichloromethane, then we have a very low binding with T and B, decreasing the solubility using dichloroethane. We increase the binding constant, and chloroform is also a better solvent, but we tried to dissolve it in methyl cyclohexane, which is a solvent that we didn't think would be as good. So you can see that it's a very apolar solvent, but the Calyx Parole was actually quite soluble in this solvent, and you can see that already by just introducing a few equivalents of the T and B molecule, it becomes completely saturated. So you can see here in binding constants, overall binding constants, that we're able to reach 10 to the 7th when we use methyl cyclohexane. So just changing the solvent would actually work in improving the sensor capabilities. I also did an experiment where we just mixed together the Calyx Parole with 10 equivalents of trinitrobenzene, and you can see here that we get a prominent CT band. Of course, the CT band in methyl cyclohexane is not as strong because methyl cyclohexane is a solvent that favors hydrogen bonding, so CT interactions are not strongly favored in this solvent. But when we add in excess of tetraethyl ammonium chloride, we only see a slight decrease in the CT band, and this is a saturated solution of the chloride. So just by changing from chloroform to methyl cyclohexane, we can show that we can actually favor complexation with trinitrobenzene. So this is something that we're still working on. But then, as Atanu mentioned, I came back to the university in 2016 after having worked in the industry. And one of my goals was to actually determine whether this compound would have a commercial application as an explosive sensor. And we're still working on that. But can we achieve a functional sensor for explosives? That is my question. And there's actually been two examples, but they're not strong examples. So Sessler and co-workers reported in 2011 that this the thiophene version of the TTF Calyx Parole could be adsorbed onto this cantilever, and then by introducing T and B vapor, they were able to show a change in resistance. So saturated T and B vapor could show that they had a positive response. So this is one example. And at the same time, my former supervisor, Jan Jeppesen, also reported that this diapropyl TTF Calyx Parole could function as a sensor for gas phase detection. And this was a similar method, but they used optics instead of electrical resistance. So this is a modified CD-ROM where they adsorb the Calyx Parole, and then they could expose it to dinitrotoluene vapors, and you can also see that there's a positive response. So these are two examples where they actually made it as a sensor. But my goal is to explore the spectroscopic methods. Coming back to the university, we reported this supramolecular type polymer, where we had the TTF Calyx Parole, and then we had this dimer of the fluorinome derivative, where we had 3 nitro groups and this dicyanomalonate moiety. And this is extremely electron poor and was able to interact with the Calyx Parole. So you can see here that mixing these two together, we were expecting to form some type of supramolecular polymer or oligomer, depending on the binding constants. And simple absorption spectroscopy showed that at different concentrations, we're able to get a strong binding. So this is an overall binding of 10 to the 5th. But this fluoronone derivative was also fluorescent. So we thought that we might be able to exploit this in an indicator displacement type assay, where we could first quench the fluorescence when we make the one-to-one stoichiometrical supramolecular polymer. And here you can see that at different concentrations, we're exploiting the supramolecular interaction. So at 23 micromolar of total both monomers, we had 53% quenching. If we increase the concentration a bit, then we would favor more supramolecular polymerization. And this shows that at 100 micromolar total concentration, we have 97% quenching. So this system at 100 micromolar might be able to show indicator displacement behavior. We also had DLS to show that we have a significant change in the hydrodynamic radius when we have the bisfluoronone present as well. So we made this supramolecular polymer, and we investigated the fluorescence increase upon introducing trinitrobenzene and also with the chloride anion. And you can see here with chloride, then we haven't got complete quenching, and we're doing this experiment at 40 micromolar. So it also depends on the total concentration of this supramolecular polymer. But as soon as we add in anions, we can see a fluorescence increase of this system, which is interesting because rarely you have a fluorescence turn on when you detect anions or nitroaromatic explosives. Anions tend to quench fluorescence. But in the example with the TNB, we have a slightly less fluorescence increase when we add in TNB, but you can still see clearly here that it increases, but then it stabilizes. So we don't get a further fluorescence turn on. So this was in 2016, and then following this work, we recently reported different types of indicator displacement assays where we used the benzene derivative of the TTF Calyx Parole and different types of fluorophores. So you can see here that we have the benzo TTF, and then we applied the naphthalene diimide and the perylene diimide fluorophores. And we can make them as monomers and as dimers. And this investigation showed that all of these systems could be applied as indicator displacement assays, but with varying efficiencies. So some of them actually gave a fluorescence turn on, and some of them gave a fluorescence turn off. Then we also showed that this rhodamine could be applied, where you can see here that it's binding in the cone conformation, and then by introducing explosives which normally bind in the 1,3 alternate conformation, we could also see that some complexation with the explosive took place and the fluorophore was released. Now to some of our present work, which we're trying to explain, is that if we could design a perfect system for an indicator displacement assay, what would the binding constants be for the analyte, for the TNB or the TNT molecule? What would the binding constant ideally be for the indicator, the fluorophore? And what would the concentration range be to get efficient sensitivity and selectivity? because as you can see from the TNB and the TNT, they fit very nicely inside the cavity of the TTK Parole. They have both CT interactions and dual hydrogen bonding interactions. But these fluorophores, based on the NDIs or PDIs, are mostly centered around CT interactions because the distance between the two carbonyl moieties is too great for them to effectively hydrogen bond inside the cavity. And I'll show you shortly. So we thought that by modifying the nitrogen substitution to something that's more sterically hindered, we were able to fine-tune the binding constants for these fluorophores, make them having less affinity for the Calyx Parole. So they are mainly working via CT interactions, whereas TNB and TNT have both CT interactions and hydrogen bonding interactions. So our idea is that if we modify the solvent and introduce methyl cyclohexane, we will decrease the CT interactions, and then we'll be able to make them more the Calyx Parole having higher affinity for the explosives. So we did this testing where we had the different substituents, and you can see here that the overall complexation for TNB and TNT in chloroform is 10 to the third. Then we have the NDIs and the PDIs with different substituents, and we have this isopentyl, the N-pentyl, isopropyl, and the mesotyl substituent. And we thought that the mesotyl would introduce the most sterical hindrance. But you can see that their binding constants are quite higher than TNB and TNT in chloroform. So if we were to make this indicator displacement assay in chloroform, there wouldn't really be any displacement because it binds the NDIs and the PDIs so much stronger. But if we switch solvent to methyl cyclohexane, we can increase the complexation with TNB and TNB dramatically to the 10 to the 8th. For the NDIs, where the distance between the carbonyl groups are not as big, they can still perform hydrogen bonding interactions. But for the PDIs, you can see that their binding constants are not increased as well. So we have this idea that if we use TNB and the mesotyl substituted pyrrolene diamide, then we actually have a system where the binding constants are very close to each other, but TNB is slightly favored. So this is our idea that we want to make an efficient indicator displacement assay using this PDIC. And you can see here that if we did the experiment in chloroform, we actually had a fluorescence turn off when we add in the TNB. So it's actually quenching the fluorescence a little bit. But if we make the same experiment in methyl cyclohexane, you can see that we have a strong fluorescence increase compared. So all of these results are indicative that we were able to make an efficient indicator displacement assay using methyl cyclohexane instead. Then a short final part of my presentation is that we're also implementing Raman scattering, which is famous for the Indian physicist. And we reported in collaboration with Emma Flood in Indiana that this molecule, again, could be applied in Raman scattering. And here we used resonance Raman. So by selectively choosing a laser wavelength where the TNB molecule doesn't absorb. So we have these two wavelengths, 514 and 785 nanometers. And you can see that the CT chromophore is still strong at 785 nanometers, meaning that if we have complexation between the Calyx Parole and the explosive, then it will absorb the energy from the laser. And you can see here that during the titration with adding in TNB, we have an increase in the CT band, and we have an increase in the Raman scattering of the nitro groups of the TNB molecule. And here it's more evident that when switching from 514 nanometers to 785 nanometers, we have an extreme increase in signal for these nitro vibrations of the TNB molecule. So here we showed that we're able to make a fingerprint of the TNB molecule when it's complexing Calyx Parole, so we can avoid other contaminants that don't absorb in this area. But the combination of the explosive binding TNB will increase the Raman scattering at this wavelength. One final experiment that we did was to do it on solid material. So we have the pristine Calyx Parole. We have the crystalline trinitrobenzene, and then we have the complexation with Calyx Parole. And you can see here that at only 10 seconds we have a signal for the nitro group of the complex, and at 100 seconds we have much more signal for the complexation. So just in the solid state, we are able to show that we can detect TNB much more efficiently than without the Calyx Parole being present. So this leads me on to what we're working on right now. So we are synthesizing a TTF Calyx Parole that is non-symmetrical. So we're introducing this alkyne moiety onto the Calyx Parole, and then our attempt is to make this self-assembling monolayer with thiols onto a gold surface. And we want to click on this Calyx Parole to the surface, and then utilize the plasmon effect of the material to increase the Raman signal. So this is a surface enhanced Raman scattering, and we're also wanting to apply the surface enhanced resonance Raman scattering to increase the signal intensity. I had hoped to be able to give you some results on this, as I showed in the abstract, but due to the COVID-19, we are severely limited in our possibilities. And my PhD student, Mads, hasn't been able to come to the US to do these experiments. So he's actually making substrates and trying to work with a Raman setup by his own without having any experience as a spectroscopist. So finally, I would just like to thank my collaborators and my supervisors. So there's Kent Nielsen, who was my PhD supervisor and initiated all of these interesting projects. And then Jan, who's now also my colleague, and we have many discussions. Jonathan Sessler at the University of Texas, which is a great inspiration for all of us. And then Amar Flood as well, because he is always able to find some interesting things on these molecules. And then, of course, Atano, which is one of my strongest collaborators, and we enjoy a lot of different projects. Harrison, who was a PhD student in Texas, who did a lot of these fluorescence measurements, and then Mads, who is my PhD student, currently working on the Raman scattering, and then Professor Jung-Soo Park at in South Korea for his collaborative work on these indicated displacements as well. And thank you for your attention. That's it.
Okay, thank you very much, Stephen, for a nice presentation. And now we are expecting a couple of questions from the audience. So Masatoshi is there, right? Masatoshi, do you have any query about
Okay, so
this system?
I have a question one, so Stefan.
Yeah.
So last one is I'm just interested for detection by using for Raman spectroscopy. So you have just mentioned over the gold surface, you just apply for something for this your molecule. After that,
Yes.
okay, then by taking advantage for plasmon enhance, right? So how you can just enhance for Raman using for this plasmon effect?
Yes. So this is more a question for physicists, but we're working together with a retired physicist at my department who's able to make these very well-defined structures where they have these cavities where the plasmonic effect is really strong, and we want to be able to make very precise structures where the plasmonic effect is within the range of the CT interaction. But there's a lot of work with just making the structures. I believe it's aluminum and then coating it with the gold as well.
Yeah.
But, yeah,
I'm just interested for what about some silver nanoparticle? It depends on the size actually, but still you can just kind of application for this as the same way.
Yeah, we aren't really set on the substrate we use. We need it to be reproducible, and because we have the access to this at our department, then we're using this. But currently we're experiment with the Raman setup and trying to change the laser wavelength as well.
Okay, thank you.
So Stephen, can you hear me now?
Yeah, sure.
So tell me how far we are to make a device with this Calyx Parole system.
Well, I have a project finance by the Danish government that runs for 2 more years, and hopefully we'll be able to reach a point where we can make a device. But I want the device to be functional for gas phase detection and having the sensor set up as a solid. So Raman surface enhanced resonance Raman would be my way to go. But as I understand it, there's a lot of difficulty making homogenic self-assembling monolayers with these molecules. So right now we're just experimenting with a plasmonic effect on a solution of Calyx Parole with explosives. But we have a lot of problems with the setup, and because we're unable to travel to the US right now, we're trying to deal with the things ourselves.
Okay,
but
that's a big problem. Yeah.
My goal is 2 years. Then we'll have decided whether this is worth pursuing.
All right.
Nice.
Good afternoon. I would like to ask a question regarding the fluorescence.
Yes.
So these components are really emittive. So how much the quantum yield? Is there any possibility used for another applications?
For other applications? I'm not sure I understand, but both the NDIs and PDIs are having applications within material science with using their fluorescence. So they are quite emitting, and I can't recall the fluorescence quantum yield, but I believe they are above 50%.
Okay. Another one question regarding the Raman spectral measurement. How do you choose the line, like a wavelength? Which wavelength will give a better enhanced peak.
Yeah. So this project from 2017 was actually that typically you would use a wavelength of 514.5 nanometers, and this would also excite the TMB molecule by itself. So switching to 785 nanometers would avoid most aromatic compounds being excited. So the idea is that you would only get Raman scattering when you have something that will complex with the Calyx Parole and having a CT interaction within this range. So that it's the idea of becoming much more selective. For the surface enhanced resonance Raman, we're working with having the right substrate with the right plasmonic effect, and then also using the proper excitation wavelength. So this is ongoing, and it's unfortunately not going as fast as I would like.
Okay, thank you very much. Because of your most of the components show absorption around 7, and using so I thought more fluorescence than the Raman signal.
But we're not working with the fluorescent compounds for the Raman. We're only doing that in the fluorescence projects. So we shouldn't have any significant fluorescence in these systems with where we're utilizing Raman.
Okay. Okay. Thank you very much.
You're welcome.
Okay, so any other question, I mean, from audience?
I have one more, can I?
Sure.
Yeah, so
Okay, please go ahead, yeah.
So I was just wondering, interesting for supramolecular polymer. So what is what kind of morphology can you just see by AFM kind of? Can you see something linear fiber-like between TTF and this fluororenon molecule, I guess?
Yes. So there has been some reports of supramolecular polymers with this TTF Calyx Parole, and I think the original one was from a PNAS paper in 2011 by Jong-Soo Park.
Okay.
And in his experience, he saw fiber-like structures in AFM and I think it was SEM as well. But I had a report in 2014 where we made these more simple supramolecular polymers. My problem was that as soon as I reached a point where it actually polymerized, it would just precipitate out of the solution.
I see.
So I think I've only reached the point of supramolecular oligomers, and as soon as I reach polymers, I need to introduce a lot more degrees of freedom to make them soluble. So I don't think it has been achieved to make supramolecular polymers with this compound yet.
I see. Okay, thank you.
Okay.
Yeah.
All right. So if there is no more question, please join me to thank Professor Stephen Baring. Okay. Thank you very much, Stephen, from my side once again.
Yeah.
Thank you, Atana.
All right.
Okay, Jana.
So now someone wants to present his work. So could you please share his? Okay. Okay. So now. Okay. Okay. Okay, Professor Ramakrishna Rao, please go ahead.
Yeah. I think Arnab can't agree. Oh, yeah.
So please take all the sessions. Ramakrishna sir.
So Ramakrishna Rao sir.
Yeah.
Requesting you. We have a one oral presentation.
Okay.
Yeah, he gonna presenting now. Then after we'll followed by the poster presentations.
Yeah. Okay.
Yeah, I will share
Or maybe we can go for the poster presentation first, and then I mean, finally, if we have some time, then we can consider that oral presentation.
Only oral is
Because oral presentation is scheduled for this session, right? Okay, then please go ahead with that.
Yes, hello, sir. Am I audible?
Yes, please go ahead.
Please go ahead.
Yes. Good afternoon, all. So I am Dr. Ranganath from Department of Chemistry, Presidency University, Bangalore. So I am intended to present my recent work, which is aim to synthesize nickel cobalt double hydroxide, and aiming to study on its electrochemical aspects. So in the introduction, so I will briefly so inform about explain about what is supercapacitors, how so basically, so in nowadays life, so we are in serious scarce of renewable resources for in terms of energy extraction and all. So one or the other, in near future, we are supposed to switch to such kind of source that can be a renewable one, and basically that can be solar energy, so using photovoltaics and all. So and the alternate energy sources such as batteries, supercapacitors, or fuel cells. So so here, so there is a basic difference between batteries and supercapacitors. So in terms of the energy delivery, energy storage, and all, so they are a bit quite different. So even this mechanism of the energy storage. So with respect to in that particular view, so these supercapacitors can deliver the stored energy at very higher rate compared to those of so batteries. So in this view, so these particular double hydroxides of nickel and cobalt can synergistically show a very significant amount of charge storage and delivery. So in this view, I am intended to synthesize this particular nickel cobalt double hydroxide, for which I used salts of cobalt and nickel. Here, very importantly, I made use of the propylene oxide, which acts as a gelation agent. So using this particular propylene oxide, so I was able to synthesize nickel cobalt double hydroxide, wherein propylene oxide acts as acid scavenger through protonation of the epoxide oxygen and subsequent ring opening by the nucleophilic anionic conjugate base. So here we can see how the hydroxides can be synthesized. So so next, so it was purified using the regular wash, rinsing and all, so, and dried to remove moisture and all. And the same material is used to study for electrochemical performance. Next, please. Yeah, so this is so once we are done with the synthesis methodology and all, so we have to characterize the obtained material for different kinds of using different experiments, such as so I made use XRD, TM, EDX, and BET and all. So in this XRD we can see so it is basically to study the phase structure of the prepared compound. So here we can see this particular material exhibits major characteristic diffraction peaks at different 2 theta values of 11.1, 22.1, 34.4, and 38.6 degrees, representing 003, 006, and 012 and 015 planes of hydrotalcite like LDH, layered double hydroxide phase. Next, please. Yeah, so here we can see, so further, this particular material was examined for its morphological aspects and composition and all. So here we can see the EDX pattern, which shows the presence of nickel, cobalt, oxygen and all, which confirms the formation of nickel, cobalt, hydroxides and also. And also, if you can see the TM images and also, it depicts the layered accumulation of hydroxides of nickel and cobalt. So we can see the layers of accumulations of hydroxides, which again pronounces the formation of nickel cobalt double hydroxides. So further, the microstructure was further examined using HRTM, so high resolution TEM and SAD patterns. So here in HRTM, excuse me for that. So So somehow it is missing here, so that planes and all. So it represents lattice fringes corresponding to different planes of nickel cobalt hydroxide. And in acid, if we trim, we can see actually well-defined circles or fringes, so which infer the crystalline nature of the prepared material. So here we can see a BET study which is aiming to have the idea on its porosity and all. So we can see nitrogen adsorption and desorption profiles which depict a loop suggesting porous nature of the prepared compound, and it shows around 15.8 meter square per gram of the specific surface area. And in BGH curves we can see the prominent pore size distribution at around 10 nanometers. Yes, next. Yeah, so in this particular electrochemical aspects or electrochemical performance of this particular material, so it is so I have experimented for it for using cyclic voltammetry and galvanostatic charge studies and all. So here we can see, so it is actually 3 electrode systems wherein I used working our prepared material onto the carbon paper as working electrode, and a reference electrode was a standard calomel electrode, and counter electrode was a platinum. So electrolyte I made use 6 molar KOH, so which is alkaline in nature. So here we can see the cyclic voltammogram, which is showing a very broad area as a area and all, which represents the charge storage in it. And also we can see strong peaks or sharp redox peaks in this particular cyclic voltammogram, which represent the Faradaic or pseudocapacitive nature of this particular material, which is in actually contrast with that of the EDLC behavior, that is electrical double layer capacitor kind of material, wherein we are supposed to get a rectangular kind of the cyclic voltammogram representing no redox peaks and all, which is mainly based on the adsorption and desorption of the charges from the electrolyte. So this particular series illustrate reversibility and it represent or directly proportional to capacitance of the material. So we can expect the redox reactions here. So the change of the oxidation of nickel 2 plus and cobalt 2 plus from nickel to nickel 3 plus and cobalt 3 plus. So means as nickel hydroxide and cobalt hydroxide when interacting with hydroxyl ions, and also it can change its oxidation state to 3 plus, forming nickel oxyhydroxide and all, liberating electrons and all. So this is the mechanism behind this charge storage and all. So from the galvanostatic charge discharge studies and all, so we can see in previous slide actually, so we can see plateaus, charge discharge plateaus, which resemble strongly with those of cyclic voltammograms, which pronounce once again the mechanism is the redox reactions or Faraday type. So at different specific currents, we have studied, I have studied the discharge capacities and all on specific capacitances and all. So at 1 ampere per gram of a specific current or current density, so I was able to find the specific, calculate the specific capacity of around 1166 farads per gram. At 2 ampere per gram, it was 1100 farads per gram, and at 5 ampere per gram, it was 1050, and at very high specific current, very high current load at 25 amperes per gram and all. So I was able to get 770 farads per gram, which is very significant. So to study the electrochemical stability and capacity retention, this particular material was cycled for several thousands times at very high specific current, that is 30 amperes per gram, and the retention capacity of this particular material was found to have the 80%, so up to 1000 continuous charge discharge cycles. So that is very important at very high specific current. So that is a very significant result from this particular material. So, and the coulombic efficiency of this particular material up to 5000 cycles was about nearly 100%. So that is also very important, and important parameters to have the electrochemical performance for commercial use. So in conclusion, so this particular nickel cobalt double hydroxides were synthesized successfully using propylene oxide as gelation agent. So it was successfully characterized and confirmed for its preparation and all. And electrochemical study shows its suitability to be used as high performance supercapacitor material. And these are few reference. Thank you very much.
Yeah. Yes, please. Any questions? Yes, thank you, Ranganath.
Thank you, sir. Thank you very much.
Audience? Yeah. Okay. Thank you.
Yeah. Thank you, Prof. Prof, you will continue now on the poster sessions.
Yeah.
Thank you.
Yes. Let us start the postal session. Please, Giri.
Hello. Hello.
Yeah.
Hello. Good afternoon, sir. Myself, Roshni Gupta. Can I give my presentation first?
Hello.
Okay.
Yes. Yes. Roshni Gupta, sir. Sir, I have asked for making my presentation first.
Okay. So your turn will come, Rosni. Your turn will come. Please wait for a while.
Just wait for only 10 minutes.
Okay, sir.
Hello, sir. This is Dr. Anupati. Am I audible?
Yes.
Yeah.
Anam, please go ahead.
Yes, sir. Actually, my name is Dr. Anupati.
Yeah, please go ahead.
Yeah. Actually, in my present work, actually, it's focused on the fractionation of microscience. Yes. So actually, unfortunately, what we have seen that the broad size distributions during the synthesis of the graphene, we are getting the broad size distribution. So fractionation is a means prior goal. After that, we are actually doing the engineering of the exfoliation. So basically, most of the scientists, most of the workers have mainly means works on the means the exfoliation of the of this particular graphene because of their enormous activity means application part. So what we did that we are using fractionation by packaged membrane, and then we are pass this membrane and by using that vacuum filtration, manifold vacuum filtrations, and so basically we are using this is a time saving, and the fractionation part is the 90% fractionated part. So basically the micron size graphene are well fractionated, which is means well studied by scanning electron microscopy, which is presented here. From the scanning electron microscopy, it is means we can see that there is a sharp narrow size distribution of that particular graphene materials. And then we also did the Raman spectroscopy also, so to check the mapping. Basically we are checking whether which portion is, because why we are actually doing Raman mapping, because we are in AFM because we cannot get the actual layer thickness, because it is a three-dimensional structure. So we are actually doing the Raman mapping, whether means to check in which portion we are getting the means I2D and IG value is more towards 1, so that we can means hello, can I mean this poster, yeah. So actually we are getting this good result, means quite good results for this purpose, and we are our main target with the fractionate is graphene, and we are fractionating is the more than 90% fractionation is occur. And from the master sizer report also we can you can see that the particular size fractionation occurs normal agitation process, and also we compare these two results, normal agitation process as well as the fractionated by track membrane. So we are getting more good result in the track-based membrane, and we are means going in the bench scale, and also we are thinking about the pilot scale one, and we are using this very simple instrument like blender, kitchen blender, homogenizer, means manifold fractionations, and we are actually using very means it is a bench scale is you can do in the simple laboratory also, and also the starting material is also easily available. This is expandable graphite, and so in conclusion I can say that the trackage membrane is very much useful for this fractionation purpose, and this exfoliation process also can be done after fractionation. And I acknowledge to thankful to Professor Pedro da Costa, my postdoctoral guide, for the financial support, and also I acknowledge to Dr. Shashikant Patel and Orange for the work, and also King Abdullah University for the characterization support. and also I acknowledge to my college, Karim City College and Poland University, and also GITAM University for this opportunity to present here.
Okay, Arnab, any questions, please? Any questions from audience? Then, okay, thank you, Arnab.
Thank you, sir.
Okay. Okay, Jaydev.
Okay, so next speaker is Jaydev.
Yeah.
Jaydev is there?
Jaydev, I think. Okay. Yeah.
Okay, so we can go next.
Yeah, go next. Kona.
Yes.
Yes, next.
Kona Abed Al-Sulami.
Yeah, Kona Abed Al-Sulami. Yes. Is he present? Kona? Yeah, then Nageswara B.
Nageswara Rao is present? Okay, okay. Okay, Nagaraju, please go to the Nageswara Rao slide.
Nageswara?
Yes, sir.
Yes, yes, yes. Go to the next. Yeah, this one maybe. Just wait.
Yeah.
Yes, this one.
Yes, Professor.
Yes,
I'm here.
Oh, okay. Now Kana Abedi Al-Sulami is present. Okay,
yes.
okay. Please go to the former one. Yeah, former slide. Yeah.
Nice.
Welcome to this poster session.
Okay.
Yeah, this one. All right, please start.
I can just wait. Yes. I couldn't control the page, right?
Yeah, so we can control from here. Please go ahead with that.
Okay, just a little while. Okay, good morning, everyone. And it's my pleasure to present my work during this session. Actually, my work entitled with synthesis, characterization, and optical properties of polyarthoncidine with orthotoluidine nanocomposite with single-walled carbon nanotubes. In this project, all the attention paid to prepare a novel copolymer with amazing filler as single-walled carbon nanotubes. Also, we compare between the free polymer with and without single-walled carbon nanotubes, and also with and without the copper oxide to see how it works, how the physical properties improve with or without. So in this work, we make 3 compounds. The first one, the free polymer. The second one, the copolymer with single-walled carbon nanotube. And the third one, the polymer with the carbon nanotubes and with copper oxide. And it's clear if we go to the results and discussion. The results and discussion, I just want to highlight it. For the steady state measurements, it's clear that when we see it for the absorption, as you see for the absorption, for the free polymer, we got a band at around 300 nanometer, and in addition or in the presence of the single-walled carbon nanotube, the absorption of the free polymer enhanced gradually by increasing the loading of single-walled carbon nanotubes. And actually, with copper oxide, there is no huge difference for the absorption. While for the fluorescence emission, and this is what we look forward, we got quenching for the fluorescence by adding single-walled carbon nanotubes, and this quenching becomes more or increased in the presence of the copper oxide, which means what? That means we have a charge transfer between our donor and acceptor, polymer and the filler, and this quenching increased gradually in the presence of the copper oxide, which is a great tool to enhance the charge transfer. As we know, the metal oxide has the properties to do that. Also, we did another analysis by XRD. For the XRD, okay, we got a peak which confirms the formation of our system. And actually, there is no huge difference with and without copper oxide, as we see. The third analysis we did, it was the same analysis. And as we see, the first image related to the free polymer, the upper row correspond to the presence of the carbon nanotubes, and the down rows correspond to the copper oxide, in the presence of the copper oxide. It's clear that the surface, how it's changed with and without it, okay, which confirms the formation of our system. Also, we did the IR spectroscopy. For the IR spectroscopy, it clears that the formation of a new band in the presence of the copper oxide, which means that which related to the metal. Also, a huge tools that we deal with it. It is amazing tools to discover the charge transfer within our system. And we did the femtosecond transient absorption spectroscopy. And as you see, for the first image in the up, this is related to the free polymer, and then related to the carbon nanotubes, and the third one, or the last one, related to the copper oxide, in the presence of the copper oxide. And it's clear that the ground state bleach become faster within the presence of the carbon nanotubes, and also the ground state bleach becomes more faster within the presence of the copper oxide. Also, we analyze the kinetic, and as we see, the decay becomes more faster in the presence of the filler, also with the copper oxides. And by increasing also the loading of the filler, the decay becomes more faster, which is related for the good charge transfer within our system, that we are successfully fabricate. This is polymer with the carbon nanotubes. And that's all. I hope I met the deadline of the time.
Yeah.
Okay, that's all for that.
Oh, okay, so thank you very much. So I think that it is a very good poster. And this femtosecond transients absorption spectra, so these are solid state spectra or liquid spectra?
This is liquid spectra.
All right. So you dissolve this kind of materials and then you get this spectra.
Yeah. Yes,
because,
you're
yes,
right.
because why I am telling, because the quality of the spectra looks fantastic. So that's why you are just little bit.
Yeah. Actually, we work with solutions because yeah, as you know, for the time resolution, we can work it. Also, we can work with the film. Yeah, it is not difficult.
Yes,
but it's fine to. Yeah, but it's fine to work with solution.
Yes, because solid state spectra you cannot get like this kind of fancy trace. So that's the thing.
Yeah.
All right.
Okay, thank you so much.
I have a question regarding the supercontinuum. How do you produce a supercontinuum as a probe beam?
I couldn't get your points.
How do you produce a supercontinuum in your transient spectra, absorption spectroscopy?
Super what?
Supercontinuum, like a probe beam.
Okay.
With the water?
You mean the bump probe?
Yes.
Okay. For the setup or what?
Yeah, in the setup, how do you produce supercontinuum light?
We have a laser pump, okay, and this is we can automatically set up.
Yeah, one is a pump, another one is a probe beam. So how do you produce a probe beam?
I couldn't get your point.
Okay.
Okay.
There are two beams, no? You have
Yes.
sample in the
adjusting to the samples, and then we have just monitor the times.
Okay.
And
the two beams are same wavelength or different wavelength?
No, different wavelength.
What is the wavelength?
It was around 350, 370.
What about the probe beam?
More than by 10 nanometer.
Okay. Okay, thank you.
Okay, thank you.
You are welcome.
Okay, thank you. Yeah, any more questions? Then we'll proceed to the Nageswara Rao.
Okay, Professor Ramakrishna, so we need to select one candidate. I mean, which one is the best poster presentation? Please give some mark to them.
Oh, okay, okay.
please don't forget that. So which one is the like the most? Please give the full number. Maybe it is out of 10. You can just select which one is the best.
Yes. Okay, Nageswara Rao.
Audible, sir?
Yes.
Say it again.
Sir, am I audible, sir?
Yeah, voice is a little bit low.
Sir,
No,
yes.
Still it is not. Yeah, still it is not audible.
Sir, am I audible?
Yes. Now it is okay. Yeah.
Good afternoon, everyone. I would like to thank the organizers for giving this opportunity. I'm going to present my research work titled Porous Alpha FeO2O3 Nanospheres as anode material for lithium-ion battery applications. So as we know, lithium-ion batteries have energy density and they have long life. That's why they are considered as the major power source for portable electronic devices. And most recently, they found important applications like electric vehicles also. But these lithium-ion batteries have some limitations for high-power applications because they have limited energy density and low power density. So how can we overcome this? In commercial lithium-ion batteries, people are using graphite as the anode material. It has low capacity, around 372, and has safety problems. That's why it is replaced by some metal oxide, and other materials to enhance the energy density. So here we are trying alpha FeO2O3 as the anode material for lithium-ion battery applications to improve the energy density as well as power density also. So we can improve the power density by replacing the bulk particles with nanoparticles. So when we use the nanoparticles, since the particle size is less, it can drastically reduce the diffusion length of lithium ions so that we can improve the kinetic properties, so that we can improve the power density. So the objective of this work is to prepare the porous alpha FeO2O3 nanospheres using microwave assisted hydrothermal method, and then to investigate its structural and morphological properties, and finally study its electrochemical performance as the anode material for lithium-ion battery. If you move to materials and methods, so we have adapted microwave synthesis method. So because this microwave synthesis it has the potential applications like it can reduce the reaction time from hours to minutes. Also, it can give the high quality products. So here the starting products are dispersed in the water and the solution is transferred to Teflon vessel. Later, the vessel is placed inside the microwave accelerated reaction system, and the system is maintained at 140 degrees centigrade for 1 hour. So after this, the vessel is cooled down to room temperature and wash the products. Further, it is subjected to characterization like structural and morphological. So we confirm the phase, hematite phase, and the compound crystal structure by comparing the XRD pattern with the standard JCPS data. Also, we estimated the average crystallite size by using Sirer's formula, which is found to be 28 nanometers approximately. Further, the structural coordination is confirmed by FAR analysis. So you can see here IR bands observed at 480 and 573. They are respectively assigned to FeO bonds in FeO4 tetrahedron, FeO6 octahedron. So later we have seen the size and shape of the prepared material by using SEM and TEM. In the FESM images, it clearly shows the formation of uniformly distributed nanospheres, which has average diameter 350 nanometers. If we use any conventional methods and high temperature we apply, there we can have the agglomeration problem. But here in the microbial synthesis, at low temperature without post heat treatment, we can get the uniformly distributed nanoparticles. That is the advantage. Later, the same image also shows that uniformly of the prepared nano materials. Also, it shows that the nanospheres are again they are consisting of densely packed small interconnected nanoparticles, which have size 20 to 30 nanometers. So this type of architecture with secondary interconnected nanoparticles will enhance the electrochemical performance by reducing the lithium-ion diffusion length. So later, we prepared the anode material by mixing this iron oxide with carbon and PVDF binder. We prepared the electrode and fabricated the lithium-ion cell inside the glow box and evaluated its cyclic performance. Can you go to cyclic performance graph? Please. Yes. So here we can see the cycle number versus specific capacity. So at 0.1 C rate. C rate is it measures the rate at which the battery can be discharged. For example, 1 C rate means we can discharge the battery in 1 hour, that is 1 C rate. So here you can see the red color indicates the discharge capacity and black one is the charge capacity. In the first cycle, discharge capacity is high compared to charge capacity. This irreversible capacity loss is mainly due to the decomposition of electrolyte in the beginning of the cycling. But the second cycle onwards, we can see both the charge values are identical to each other, which indicates the good lithium insertion and de-insertion into the Fe2O3 structure. In the second cycle, it exhibits the capacity around 1000 milliampere hour per gram, which is 63% higher than the graphite, which you are using in commercial lithium-ion batteries. So later, we want to investigate its stability at high C rates. When we want to draw high currents, we want to check the stability of the material. So we recharge at high C rates like 5C, 10C, 20C also. It exhibited good cycle stability with small reduction in capacity. And further, we recycle the battery at 1.1 C rate to check the regainability of this. When we bring back the capacity value to initial value, when we change the C rate from 20C to 0.1 C, it indicates the good reversibility of the material at high C rates. The conclusions, we prepared the alpha Fe2O3 nanospheres within short time using microsynthesis method. We confirmed the phase and structure by using XRD analysis. TEM shows the formation of interconnected nanoparticle structure. And finally, as the anode material for lithium-ion battery, it exhibited good electrochemical performance and good heat capability. So acknowledgement, Professor Raman Spectroscopy is thankful to UGC for awarding the faculty.
Yeah, thank you.
Thank you, sir.
Sir Rao. And any more questions, please, from participants? Any questions? Okay, thank you, Nageswar Rao.
Thank you, sir.
Yeah, Roshni Devi, Roshni Gupta. Roshni.
Yes, sir. Yes, sir. Yes, sir. Am I audible?
Yeah.
Hello.
You are audible.
Am I audible, sir?
Yeah.
Yes. Okay, sir. Okay. Good afternoon, everyone. First of all, thank you so much for giving me opportunity to present my work here. and the title of my paper is Review of CMOS Technologies in Mixed Signal Design. And in this work, I have basically presented the CMOS technology in floating gate technique. Floating gate MOSFET has the advantage of voltage tunability, by which we can program the threshold voltage of the MOSFET by programming the threshold voltage by one of its input terminals. So so the question arises why we need to why we need to change the threshold voltage. Threshold voltage is actually the amount of voltage required to switch on the particular device, whether it is a transistor or any circuit. So it is very important to tune the threshold voltage of the device. So for that, I have used floating gate MOSFET, and in this work I have designed a floating gate MOSFET based inverter and compared its performance with already available CMOS inverter, which is already available in literature. So I will start with the introduction part. Basically the CMOS digital circuits with low power and low voltage consumptions are without having much loss in speed are important for circuit designers. And we know that there is a trade-off between power and delay, since they are inversely related to each other. So it is very important to design the circuit with low voltage and low power consumption. And the performance of the inverter can be characterized by voltage transfer characteristics as well as transfer characteristics. And in this paper, I have obtained these two characteristics and compared for CMOS and FGMOS. So the transient response has been obtained by the given formula, that is TP is equals to TPLH plus TPHL divided by 2, which is actually the propagation delay from high to low and low to high. And from these characteristics, we have obtained parameters like switching threshold voltage, which we have obtained by using voltage transfer characteristics and noise margin, and for propagation delay, I have obtained the transient response to ascertain the performance of CMOS and FGMOS inverter. Now I will show you the results part. In the first two figures in the result part, that is figure 5 and 6, shows the voltage transfer characteristics of FGMOS inverter at different values of bias voltage of P and N channel FGMOS. It shows the range of the switching threshold voltage varying from 0 to 1. Then we have comparative voltage transfer characteristics of CMOS and FGMOS inverter. And further, as I told earlier, that I have also obtained a transient response of FGMOS inverter at bias voltage of P and N channel FGMOS. In figure 6, it can be seen that the propagation delay varies for high to low, low to high, and for figure 9, it varies from low to high in the left and right side of figure 9 and 8. And figure 10 and 11 shows the delay at different values of bias voltage of N and P channel FTMOS. For figure 10, it is delays minimum at 0 voltage for bias voltage of P channel FTMOS, and it is minimum in figure 11 for bias voltage of N channel FTMOS, that is for 1 volt. So by suitably choosing the value of these parameters, I can adjust the transient response, that is the propagation delay, and by propagation delay we can optimize the speed of the digital circuits. So I will conclude my paper. In this paper, the proposed FTMOS based circuit has switching threshold voltage of 0.4 volt and noise margin is 0.25 volts, which is less as compared to CMOS inverter having a switching threshold voltage of 0.5 volt and noise margin of 0.009 volt. Similarly, propagation delays are also decreased in FGMOS based inverter, which is 0.2 0.2 nanoseconds for FTMOS, and it is 0.4 nanoseconds for CMOS inverter. So, and all these circuits has been verified using PSpice simulations using level 7 parameters in 0.13 micrometer CMOS technology with the supply voltage of 1 volt. And these are the papers I have referred for the work. Thank you so much.
Okay.
Yes,
Audience?
sir.
Any questions from audience? And thank you, Roshni.
Thank you, sir.
Okay, Professor Ramakrishna. So I have a request from Jaydev. That is the poster number 7. So can you please allow him to speak his poster?
Okay, go ahead.
Okay,
Please.
okay. Thank you. Thank you.
Yes,
Yeah.
sir. Am I audible? Yes, sir.
Yeah.
Yes, sir. Yes, sir. So I'm presenting my poster, a highly efficient luminescent explosive sensor based on 1 pyrene iodide ligated gold cluster. School of Engineering and Technology, National Forensic Sciences University. So now we are seeing the ligand stabilized luminescent gold cluster are important class of functional nanomaterial due to their versatile application, particularity in the imaging area of the bioimaging and sensing trace level and light. Moreover, compared to other luminescent nanomaterial, as for example, quantum dot and lanthanide nanomaterial, gold cluster could be the potential alternatives for in vivo imaging study account of their toxic nature. So in my work, please see whole poster, sir. Yes. In my work, in this scheme 1, I have synthesized, first of all, I have synthesized gold cluster with aspect ratio. Then I have synthesized pyrene iodide in our laboratory, and then we was mixed in comparative ratio, and then here you can see when we are mixing pyrene in gold cluster, excimer emission is turned on. And that I will apply on TNT adductor for titration. So this is the synthetic route of 1 pyrene iodide ligated AU nanocluster pyrene and schematic representation of sensing mechanism involved in supramolecular. Here you can see the when we are adding TNT deadductor, the excimer emission is turned off, and so same as it is study we have done by fluorometric titration. When we here you can see the fluorometric titration, the emission is totally quenched in case of. But in case of TNT, this is not aromatic. These all are for aromatic nitro aromatic explosive. But in this case, one we have also titrated aromatic explosive. So here you cannot see the emission quenching. So this is my temp photography of gold cluster and also nanode, and this is UV graph. And here you can see the more potential when we are adding pyrene gold cluster characteristic, and then and D, this is D. This is pyrene iodide emission spectra of the pyrene iodide, gold pyrene iodide, and CTAP stabilized nanode pyrene iodide spectra. So this is the all the UV characteristic. Here you can see the emission, strong emission peak of the. Then same thing we have also applied solid state titration for explosive nitro by thin film. So we make the thin film. Here you can I show the morphology in my poster. 20 micro mm by 20 micro mm. We measured the by FM. Then we have same solid titration done titration against solid thin film against explosive. So here you can see the same quenching in solid state phase we have observed in spectropolarimetric titration. So, and in the detail of quenching of efficient, we have showed the data of the TCSPC in detail emission. So there are no difference between the mode time. So we have concluded that it will be also applicable on that. So this is my summary. Pyrene iodide ligated gold cluster was synthesized and originated from excimer formation. It can be luminescence chemistry for detection of nitroaromatic explosive through emission quenching. TCSPC, I have showed the TCSPC. Then vapor phase explosive, I have above I have showed the thin film data, so that here you can see the quenching is sensing is done. Then luminescent gold cluster could be also used developing for latent fingerprint. Here you can see the left side in my last poster. Here you can see we have tried to develop the latent fingerprint so that cluster powder. So here you can see the sensing ability, and I have shown the photographs all of them.
Yes. Any questions from participants? Yes, then thank you, Jaydev.
Okay, sir. Okay.
Yes. Next, Shipat. Yes.
Yeah.
Next participant, Shipat.
Yes, sir.
Yeah, please.
My voice is audible now, sir? Yes, good afternoon, sir. Me, Shipra from GITAM University. I'm a research scholar. So as it's an energy part, so all are coming with their own ideas of research about the bunch of ideas. I also came with a bunch of ideas saying that my research work here is synthesis of electrochemical studies of NaCO2 as a cathode material for aqueous reachable sodium-ion battery. As we said that already, the demand for energy storage system is very important here. So I came up with an energy storage system. So in this, I had synthesized two material like for anode and cathode. As anode, I had prepared Na-Ti2PO4, and I had synthesized cathode also NaCO2 cathode material. And we can see that in the results and discussion part, I will directly go for result and discussion. As we can see, slow combustion method, I had synthesized one cathode material, and from the cathode material, like a 400 degrees Celsius, I had synthesized and I had removed all alkaline particles, and I got cathode material. And from characterization, you can see that both anode and cathode I had shown there. As anode material, I had synthesized by a rapid method, like autogenic temperature. So in this both I had synthesized, and I had done a characterization through for SEM analysis. I had gone through that, and also IDAX. And the main thing is like stability. Stability is very important in a battery. So while you are doing any battery material, stability is very important. That's why we gone through a TGA. So in thermogrammetry analysis, you can see that only 12% decrease, that is almost more than 300-400 degrees Celsius. So then the main important work we had done is that about electrochemical studies. See, as we go down, we can see that electrochemical studies, so please little bit, if we go down, like electrochemical studies, we can see that there is a modern technique we are using for oxidation reduction properties, like the electron transfer. As I said, NaCO2 I had run in aqueous electrolyte. So my work is mainly about aqueous reachable sodium-ion batteries. So the two peaks, you can see that the sharp peaks of like with between the voltage differences and the delta AP, we can see the peak potential of 0.1 volt. And once we confirm that there is an like electron movement, I mean oxidation reduction movement is there, then we go on with a different electrolyte study. So it is clear that I had done 2-3 different electrolytes, and I got a very good result in like sodium sulfate, and I'm gone through the different scan rate. In scan rate, we can see that the peaks, how it is, as in a different scan rate, the peak movement and the distance, we can clear that the plot, the reversibility of the battery, we can say. And after that, we have to go to the final thing is about the galvanostatic charge discharge experiments. And in the left side, you can see the experimental setup, what I had used the cell, and the electromagnetic studies I had done only through that the Protestant biological instrument from France. So in galvanostatic charge discharge experiments is a final study what we have to do when the battery is, whether it's working or not. In this study, I had used only two material, no other like platinum electrode, or I had not used, only the two anode and cathode. And I had run by giving of current, and I got almost 89 milliamps of current. I got so the total energy of this, we can say that 1 volt. And I had run with the different C rates like 0.1 C, 0.2 C, and 1 C. Also I had run, and the main thing is at 1 C I got almost 34 milliamps of current, which is nearer to some of the non-aqueous electrolyte batteries. So, and I also done about the Coulombic efficiency, like like different cycles. So, as we see that almost 55 cycles, it ran very good. So I say that our sodium ion battery is getting a little bit very good current of like 800 mAh. So I confirm and conclude that conclusion that synthesize is one of a cathode material by an low temperature combustion method, and even I had synthesized anode material also here by an rapid method. So both I had used here, and through XRD and some TG and DSC, I had confirmed that whether the material is which having a very good agreement with that. So from electrochemical studies, I confirmed that the reversibility is perfect and which can be used for battery applications. Also the galvanostatic is very important. You see, as I said that anode, cathode, and also electrolyte. I prepared one full cell, and we had run with 0.1. As you can see that current may be the less, but we cannot compete with lithium-ion battery. But in future, we can use some I had not used any other enhanceable properties. Like I had I had prepared with the carbon and I had run. I had not used any other more electron enhanceable property materials. So this I will conclude that this of my research work, and I thankful for an funding DST and mean for GITAM University for all supports and giving such a beautiful platform here to express my research work. Thank you, Honorable.
Okay, very good, Shipati. And yes, any questions from participants?
I just want to thank Siprot because I like your poster. It is a complete it is complete and organized poster.
Okay,
and
thank you, sir.
I like your honest opinion as well, because you cannot compete with the lithium-ion battery.
Yeah, sure, sir. But
so that's the thing. And John Goodenough already got the Nobel Prize maybe last year, right, on the lithium-ion battery.
Yes, correct, sir.
At the age of 97 years. So you
that's
understand.
What, but
so if you can develop the sodium-ion battery, then you have to wait for 97 years.
Yeah.
All right. So yeah. So who is the next one?
Yes.
Hello. Thank you, sir.
Yes, sir. Hello. Am I audible, sir?
Yeah, you are audible. Proceed.
Okay.
And
thank you.
4 minutes only.
Okay, sir. Thank you, sir. Thank you. Thank you for giving me this opportunity to present my work, the distribution and source ecological toxicity of polycyclic aromatic hydrocarbons in surface sediments. So we all know that nowadays the organic contaminants are increasing in both in aquatic environment as well as in our atmosphere. So I have studied only 16 pHs which were assigned by United States Environmental Protection Agency. These are starting from 2 rings to 6 ring pHs. This is my study area, and the objective of my research work is to investigate composition pattern of pHs in the sediments and to evaluate their equivalency factor, toxicity equivalency factor, and sediment quality guidelines. And I have extracted these pHs from sediments by using those the liquid extraction procedures, and this is in my materials and methods. I have used the evaporator to carry out the DCM fractions, and I have used the deuterium labeled pHs as surrogate standards. And finally, I have concentrated my sample volume to 20 microliter by using the pure nitrogen gas. And this is my GCFID conditions of instrument. And I have used principal component analysis and diagnostic ratios for source apportionment, where I got these pHs were coming from mostly from petroleum combustion and biomass coal combustion sources. In table, I have calculated the toxicity equivalent factors and the toxicity equivalent quotient, and here I got the result that 3 rings, the middle ring pHs were most abundant in sediments. Okay, can you please scroll down? All right. Okay, overall higher concentration I got at the sites where the port activities were intense and the traffic of boats, large ships, and wastewater discharges in their tidal regime. Fine sediment particles might have favored this deposition of polycyclic aromatic hydrocarbons. So, thank you, sir.
Yeah. Yes. Any questions, please? Yes. Thank you, Shankar said.
Thank you, sir.
Okay.
Hello.
Yes, Tapan Kumar Shankar.
Am I audible, sir?
Yeah, you are
Okay.
audible.
Good afternoon, all the honorable guests and the organizing committee, to give me an opportunity to present my work in that international conference. My name is Tapan Kumar Shankar, I'm the research scholar of Department of Chemistry, NIT Jamshedpur. So my title is Characterization, Seasonal Variation and Source Approximation of Black Carbon Aerosol over an urban area. So as we know, the air pollution is one of the most serious problem in the environment. We know the air pollutant like carbon dioxide, carbon monoxide, night, and many so on. But black carbon is very serious problem in our environment, and very few people are known about the black carbon. So the black carbon is the second most polluted air polluted in the environment after carbon dioxide. So what is black carbon? Black carbon is a soot particle. Its size is very less. That means its size is 2.5 micrometer. Is the particle of the black carbon size is 2.5 micrometer. So it is emitted by the incomplete combustion process for both human as well as natural. The elevation region of the Himalayan region and the Tibet, BC produce a heating and also the effect of the Africa. So the most thing, the black carbon has a relatively short lifetime. So what is the objective? So our objective is the research focus on the BC in the urban area over the Eastern India, and to create the public awareness about the black carbon pollutant, and also to identify the potential sources of BC. So this is a one type of device is called the athalometer. We can use to measure the black. We can use the measure black carbon by the athalometer is the one type of device. We can easily monitor for the black carbon from the environment. So as we see in the figure, this is very serious effect of the health, just like the lung cancers and the heart disease, and so on. So many problems are created by the black carbon. So as we see our study in the winter, summer, monsoon, and post-monsoon, the highly concentration of black carbon are found in winter season, because in the winter season the mixed layer height is very low compared to the other season. So that's why the our system monitoring the most concentrated black carbon in the winter season. And as we saw, as the graph you saw the table number 3, as in the morning and the evening time the concentration of black carbon is high, because at that time the mobility of vehicles and the activities of industry are more. So we observe the more concentration of black carbon. And here the see the some figure of the Indian. This is actually basically these are the trajectory model where you found how air are present at a target position by the direction of wind. So we can see which directions of the airborne are coming from our targeted location. And table number 5 are also in the Julian day, means every day we calculate the black carbon aerosol and put into a graph. So my conclusion that the black carbon is one of the most pollutant particle in the environment, and its high concentration was found in winter season. So my conclusion and acknowledgement thanks to NIT Jamshedpur, and I am working for in a SERB project given by the DST. Thank you, sir. Thank you so much.
Okay, good. Tapan Kumar, any questions, please? Yes, then thank you, Tapan Kumar.
Thank you, sir. Thank you very much.
Very
Yes.
good presentation.
Next, Lalita Gummadi.
Hello?
Yes.
You hear me? It's okay, I am with you.
Oh, okay.
Okay, I start?
Yes, please start.
Yeah.
Okay. First of all, I am very pleased to be with you in this conference to present my paper, Effect of Sodium Hypochlorite and Extracts of Some Plants on Pathogenicity of Scleratum Sibovarium. Scleratum Sibovarium caused white root disease. It is a very devastating disease for onion in many regions of the world. This devastating disease has sclerotia. The sclerotia or propagules of this disease remain in the soil for a long period. It is extend about to 20 years. Many approaches have been used to control white rot disease of onion, including using fungicides, biological control, and composted plant hosts. Many workers also made effort to find the natural resistance for this disease in the germplasm of the edible species of the genus Alia. There is also many attempt to produce genetically modified resistant onion, but unfortunately, all this effort have limited impact on the pathogenicity of this disease. This work, the objective of my work is to evaluate the efficiency of low concentration of sodium hypochlorite and the carrot root extract and eucalyptus leaves and fruits in controlling this disease. The first experiment will study the effect of water extract of carrot roots, eucalyptus leaves, and eucalyptus fruit on the linear growth of Sibovarium and the low concentration of sodium hypochlorite. As you see in the table, first table, you can find that all these extract have decreased the growth of the fungus on the bee media. But as you see, low concentration of sodium hypochlorite inhibits the growth completely of the fungus. So we continue with this concentration. Second table, please. Would you slide a little bit? We study the survival of Scleratum, Sibovarium scleratum in soil, amended with sodium hypochlorite. We used 15 part per million, 10 part per million, and 5 part per million, and 1 part per million. As you see, percentage of Scleratum recovered in soil, as seen in the column on the left, you'll find that the percentage of viable Scleratum is 0 for the low concentration of sodium hypochlorite. The recovered Scleratum completely lost their viability at low concentration of sodium hypochlorite and were completely disappeared. The third table, please, third table, we study the effect of sodium hypochlorite supplied to the soil on the incidence of white root of onion seedling. The plant weight slightly decreased in soil supplied with low concentration of sodium hypochlorite. As you see in the table, the percentage of healthy plant in the soil supplied with low concentration of sodium hypochlorite was 100%. So it has no effect on the growth of the plant. In the last, we studied the effect of sodium hypochlorite on the soil microflora after 1 month and after 2 months. Sodium hypochlorite caused minimal decrease in the number of bacteria and fungi after 1 month. You compare this in the second column for control 5.9 and after 1 month 5.75. But after 2 months, no significant difference in the total frequency of bacteria and fungi were observed. In the column on the left, you can find after 2 months for the control 0.65 and for 1 part per million 0.65. In conclusion,
yes, please.
Yes, just a minute.
Hello.
Yes, yes. This study shows that an extract of carrot roots, eucalyptus leaf, and eucalyptus fruit reduced the growth of Scleratum Sibovarium, but the degree of the reduction was varied between the three extracts. On the other hand, sodium hypochlorite completely reduced the growth of Scleratum in vitro and under greenhouse condition at very low concentration. So I think it is recommended to control this pathogen. And that's all. And I'm waiting for any question.
Yeah. Okay. Any questions, please? Yes, thank you. Some more.
Thanks a lot.
Yes, next, please. Yes, Pooja. Yes, Pooja. Is it Lalita Gumadi is there? Or Rama?
I can't.
Yes. Okay. Okay, payment.
Yes.
Yeah.
Hello to everybody. Thank you very much for giving me time to share this presentation.
Yeah.
My poster is about the development of amine functional isolate imidazole framework, PEBAX mixed matrix membrane for CO2 separation. Recently, gas separation membranes has fascinated a lot of interest due to requirement for high purity gases in industry sectors such as methanol production and also environment issues. So the researchers were inspired to develop mixed matrix membrane because it's have a low prices. Because you have a low prices in compare of the, for example, inorganic membranes. And also we have less problem and less complicated procedure for producing polymer membrane compared to inorganic membranes. Also we try, or aim is to try to get upper bond curve and to have good selectivity and permeability. In this work, my aim is to make a mixed matrix membrane by using polyethylenediamide, which is PEBAX, containing ZIF69 metal organic particles, which I will functionalize with NH2 amine for which dispersed in the polymer matrix to separate CO2 from methane. And also we also study the particles fillers, which from 0 to high increasing. As you know, nowadays, then the effect of greenhouse gases, which is affected, the CO2 gas has directed global climate change, leading to highly concentration by numerous researchers. Methane gas is included as the key component in biogas. So, and natural gas also same. But we should separate CO2 from the other gases such as CH4 in the natural, for example, gas line. I mean, the application of this membrane could be used as, for example, in nowadays we use amine in the refinery, but these have a problem which for reducing the water in the amine. So we want to reduce the energy and less toxicity of this procedure. So I tried to use this one, and then mixed matrix membrane containing distribution inorganic fillers in the polymer matrix, as I told you, and included and recognized for metal organic frames of zeolite. And in this case, we increase the fillers from 0 to increase the higher 5 by 5% divided. And I use the PEBAX. The PEBAX is a good rubbery polymer, which shows a good resistivity against the heat, and also have a good flexibility for this one, and have a good permeability. And my objective of this this paper is to synthesize and characterization ZIF69 or PEVAX mixed matrix membrane, where I'll also functionalize ZIF69 or the PEVAX, and also to study and evaluate permeability and selectivity properties of this functionalized ZIF69 PEVAX mixed matrix membrane. And the result discussion, please. Can I? Yeah. The applicable result in relation of morphology. Yes, can you go to the result discussion? Hello, can you hear me?
Yeah, Nara sir, please.
Can you scroll down to the result and discussion?
Scroll down. Yeah, this is the end. Yeah, yeah.
Hello, can you hear me?
Yeah, we can hear you.
Sorry, it's an interruption for my internet. Sorry. Can you scroll down to the result and discussion? Yeah, thank you.
Yeah.
And the applicable result of the evaluation of the morphology and gas separation properties of functionalized ZIF69 PEVAX mixed matrix membrane is good for a potential property for gas separation. For gas separation in industry and in the other applicable application. And would you please scroll down to the result and discussion? Hello?
Yeah, it is the end, right?
Yeah, okay. Yes. Yes, the right side. Can I say
okay, right side. Okay, then you need to go up, right?
Yeah, sorry. So the function. Yeah, scroll down, please. Yeah, down, please. Yeah, material methods. Recently, gas membranes has fascinated a lot of interest due to requirement of high purity of gases in industry sectors, such as methanol production from CO2 fuel and fuel cell. And so the researchers were inspired to develop this mixed matrix membrane and yes. Okay. Can you scroll down?
Scroll down. Yeah.
Yes, the permeability tests are accomplished with the carbon dioxide and methane. Will be the 3 bars and the layers. So we will try to see whether their permeability and selectivity to see in compare of the Robson upper bond. Yeah, thank you very much for audience.
Okay, thank you very much. So I have just a query. So these membrane-based systems are how much effective if you compare with the metal organic frameworks or some organic frameworks?
Well, so this, as you know, zeolite is a subclass of the metal organic frameworks. So we use these inorganic fillers by functionalization by amine. So my aim is by functionalization by amine, I improve the affinity of the CO2 to this membrane, because as you know, the amine is a good material for absorption in the I use this for adsorbent. So by functionalization by amine, I increase this affinity to CO2. And also the study to different percentage of the fillers of the functionalized ZIF, zeolite.
Okay, Payman. Okay. Thank you very much. That's a good technique, I think.
Hello?
Let's see. Yeah.
Hello?
Yes, you can hear me?
Hello?
Yeah, you can hear me now? Hi, Payman. All right, so we can go ahead. Okay, so who is the next? So
it's me, Shazwani.
Okay, please go ahead then.
Yeah, thank you very much, sir. I'm Shazwani. from Faculty of Engineering, University Putra, Malaysia. Today I'm presenting about the absorption of removal study on the absorption of ferrum from groundwater using waste-derived adsorbent. The increment of the ferrum in groundwater has put into concern many of the Malaysian because the ferrum exists in natural reaction of the groundwater in Malaysia due to the hydrogeological reaction, also lithology of the soil, depends on the lithology of the soil. However, if we taking into account there is no extra contamination, we believe that in the aquifer is rich in organic material. Therefore, there will be high possibilities for the depletion of oxygen due to the organic decomposition. Therefore, ferrum in the form of ferrous will exist. So groundwater containing iron has become a major concern. Therefore, my research team has developed two types of adsorbent. Can you scroll up, sir? Thank you. All right, so scroll down. All right, so two types of adsorbent. The first one is derived from sagu palm bark, and the second one is derived from sawdust. Yeah? So the main, the aims of this study is to develop the adsorbent derived from this kind of waste. Yeah? So can you scroll up, sir? Sorry, thank you. Okay, so we have tried to improve the performance of the adsorbent by applying the heat to this kind of waste, because when we apply the heat, the pores of the adsorbent will increase. This allow a better absorption capacity. So when we improve the absorption capacity of the adsorbent, we further improve with the submerging into the sodium hydroxide. Therefore, we managed to develop a new adsorbent. So in order to further continue at large scale with the column study, we started with the batch study where we need to find the optimum dosage. Once we have found the optimum dosage, then we managed to find a better quality of groundwater. Can you scroll down, sir? Okay, so this is for result and discussion. It can be clearly seen. There are significant improvement, especially in the form of concentration of ferrum. The initial concentration of ferrum in raw groundwater sample is about 0.83. Then the improvement can be clearly seen here, where the concentration of ferrum has been reduced about more than 65% to 0.11 and 0.13. For sagu, pambak, and sawdust respectively. Yeah, so the standard, the drinking water standard being set in Malaysia is about 0.3. So this has been proven by applying this technique. We can remove ferrum and also some compounds of colors, chemical oxygen demand. More than 70% of chemical oxygen demand has been removed, as well as biochemical oxygen demand. So by removing these particles, especially ferrum, we managed to remove a total dissolved solid as well. So you can see this is a clear. This is the color of the raw groundwater in Malaysia. So this appears after 1 hour after collection. This is due to the reaction of ferrum with oxygen, which form ferrous oxide. So that this is the color of the water after the treatment. The first one with the sagu pampak and the second one with sawdust. The conclusion for this study is we have found that the newly developed adsorbent managed to reduce the pollutant up to more than 83% for both adsorbent, and is the same findings also happen to COD and BOD. So we did conduct study on the Lacquer isotherm. We found that this is the isotherm that fits well to our adsorbent. Yeah, so I think that's all my presentation. I would like to thank the organizing committee. Many congratulations for organizing this kind of event, and I would like to thank the funder for this project, which is Tenaga Nasional Berhad, the electricity generator in Malaysia, as well as the remote sensing agency of Malaysia. Thank you very much.
Okay, thank you very much. It is a very timely presentation, and I appreciate that, because this groundwater problem is a real problem and a real environmental problem. So that is a, we need to explore basically these kind of things rather than doing the hardcore chemical research. Yeah,
thank you,
so
sir.
that's the good thing. Yeah, I encourage you to do that. All right, so now who is the next?
Good afternoon, sir.
Jairam. Okay, please go ahead. Yeah.
Good afternoon, sir. This is Dr. Jairam Krishnan. I'm working as a researcher in the Biophotocatalytic Laboratory, University of Guanajuato, Mexico. Today, I would like to present my recent work about the low-cost and high-performance photoacoustic transducers for future innovative cancer treatments. In this work, we have developed carbon, nanoform of carbon from candle soot. The candle soot also mixed with the PDMS and make a nano composite. That nano composite analyzed with the photoacoustic transducer generation. Particularly, why I want to work this material and analyze the characteristics of this lens, because of laser generated focus ultrasound is one of the growing technology that is used for to develop surgery, that is mean blood-free surgery based on the cavitation treatment. We can focus ultrasound and detach or fragmented in a single cell, or for example, we can remove the mole. That kind of surgery method is called a histotripsy. This histotripsy need a piece of electric transducer. That presently available materials are very low capable of producing frequency and how to say, the amplitude, ultrasound amplitude is very low. So my work is fulfill this need to improve the high amplitude and high pressure photoacoustic signal by this material. So in this work, we developed a carbon nanoform from the candle shoot that deposited over glass slide that collected. After that, mixed with the PDMS. That mixer is a nanocomposite over the plano concave lens that is commercially available. So in this work, I have used a 2.5 centimeter focal length of the plano convex lens. Then could you scroll down? Yeah, I have used the NDI laser 532 nanometer to excite the to pump the lens, that the photoacoustic lens, and we developed a sensor, photoacoustic sensor with the PVDF, polyvinyl fluoride material, and that connected in the oscilloscope, also controlled with the software's moving platform. To each steps, I moved like each 1 millimeter and check the focal length. Is a photoacoustic lens. So I also check the power versus peak amplitude. So from 1 to 5 millijoules per pulse I used, and beyond that it is very hard to pump with the lens because of it going to break because of high energy. And this the left figure is pumped with peak amplitude, and the right figure is photoacoustic characteristics of the lens, particularly developed with the carbon nano composites. And in the another plot number 4, you can see the lens behavior and the focal length also. It is about 48 millimeter, but the real lens focal, the optical lens focal length is 25 mm, but the acoustic lens is a 45 mm. So it is completely different from the optical, and this is a completely thermal effect, and all the setups are working under the water because the air velocity of air is sound velocity of the air is 343 meter per second, but inside the water it is a fourfold higher, like 1460 meter per second. So we use everything inside the water tank, and this most of the acoustic experiments have done in the water. And based on this my work, I can say it's a low cost material because of we can perform from the candle suit. So this one is good for future blood-free surgery. Conventional surgery we can eliminate, and we can use this kind of histotripsy surgery method to bifurcate the cancer cells. And I would like to thank CONACYT, is a Council of Science and Science and Technology of Mexico, for this project. Thank you very much.
Okay, thank you very much. So I don't have any queries, but I have one op chemistry query. Are you from Mexico now?
Yeah.
Because it is a very early morning, like 4 o'clock. So you wake up at maybe, or to attend this poster session.
Yes.
Okay, we are grateful. Yeah, we are very happy. Okay.
Thank you for the opportunity. It's a great
thank you very
pleasure
much.
to participate.
All right, thank you very much. All right, so then we'll go for the next presenter. So who is the next?
Yes, Sudeep Bhattacharya.
Oh, Sudeep Bhattacharya. Okay, Sudeep, yeah.
Yeah, the preparation and application of graphene as a nano-absorbent for dispersive solid phase extraction of multi-class multi-residue in vegetable. The primary objective is that to develop a method that can be regular monitoring of pesticide at a very low cost. The traditional dispersive cleaning reagent that is primary, secondary amine PSA, that is C18, it is at a very higher cost, and it is very difficult to regular monitoring in cost sensitive issue. So that's why it is a primary objective to develop carbon nanomaterials that can have the absorbance criteria, actually absorbent properties, that can absorb as a pesticide, a different class of pesticide, not only that is organochlorine, phosphorus, or synthetic pyrethroids. That is a different class of pesticide. That is, first of all, we prepared the graphene oxide from traditional hammer method. It is a slight modified hammer method, and that graphene oxide, we examined that it is a nanoparticle or not, and then we applied as a solid phase absorbent and the Coechar's method, and that's also a modified Coechar's methods, and then we reduced the volume also, and compared the recovery study compare with C18 and primary, secondary amine, and also and so on. The recovery criteria shows that most of pesticide are shows good recovery percentage towards primary, secondary amine and graphene also, whereas C18 is a downwards curve. The Coechar's methods recovery studies shows that a C18 is very lower percentage of recovery compared to PSA and C18, but in compared with the cost-effective calculation, that is the PSA, it is almost 12,000 to 20,000 per gram, actually, according to their purity. But graphene oxide is a very homemade nano-absorbent that can use for recovery cleaning reagent, so that we can use as a absorbing criteria, absorbing reagent, and the objective to prepare the sensitive and cost-effective method of pesticide analysis in vegetable using gas chromatography, actually. So preparation of graphene oxide as a nano-absorbent and comparison on its efficiency of cleanup material in vegetable matrix, and the recovery criteria shows that efficiency is very much acceptable, and also it can be used as a regular monitoring purpose for in Quacher's method for monitoring of pesticide residue in different cluster of vegetables. That is also we have studies in different matrices like cabbage, chili, and so on, and different content of pigment also. And graphene oxide shows good result among those substrates. So the conclusion is that the graphene found to be quite satisfactory result with a relative standard deviation that is almost less than 12.8% for all 30 pesticides. We have selected 30 pesticides, and study shows the graphene oxide has significant potential as a encouraging new absorbent of pesticide residue analysis of vegetable. And graphene mix cleaning up method proves that the best providing average recovery also, that is also said that is a 77 to 118, that is quite acceptable for multi-class residue and group pesticide extraction. And graphene can replace as a new generation nano solid phase absorption cleanup reagent in modifying technique. So this is the study, and thank you. Thanks.
All right, Sudeep. So
hello.
Maybe we need to arrange much more. Yeah. Hello. You can hear me?
Okay, sir. Okay, sir.
Oh, yeah. So it seems to me that you are a little bit nervous. So maybe we'll organize another meeting and give you the opportunity to present your work so that you will be like habituated with this system. But anyway, it looks like very good study, and I'm expecting a couple of questions from the audience. So from the audience, if you have some query, you can just come forward. Anybody is there? All right, so then we can go to the next slide. Okay, thank you, Sudeep, once again.
Okay, thank you, sir.
All right, so who is the next one? Pooja Rani. Pooja Rani is there?
Oh, yes, sir.
All right, please go ahead then.
I'm audible, sir?
Yes.
Okay. Good afternoon, everyone. Myself, Pooja Rani from Guru Jambeshwar University of Science and Technology, Hisar. I'm presenting my poster on the topic thermodynamic study of ionic liquid mixture for CO2 capture. As we all know, liquid or liquid mixtures are used excessively in the chemical and pharmaceutical industry, but most of the chemicals used are the organic chemicals, which are highly volatile and flammable, which tends to have fatal effects on the human beings and the surroundings. Moreover, if we talk about the greenhouse gases, then the CO2 is one of the major pollutant and contributor to the greenhouse emissions. We are working particularly on the liquid mixtures that can be used to capture the carbon dioxide. We are also trying to provide the alternative solvents and superior absorption system which have the favorable energy performance, like low solvent loss and the less energy consumption. If we talk about the ionic liquids are the compounds which are claimed as green compounds with extensive application in different fields of science and technology. These ionic liquids are formed of organic cations and either organic or inorganic anions. These cation and anion are combined together by strong Coulombic attraction. But due to the unsymmetry in the size of these cation and anion, these have the melting point less than about 100 degrees Celsius. So these are also liquid at the room temperature that we classify into a separate branch as RTIS, that is the room temperature ionic liquids. So in this ionic liquid, there are multiple possible combination of various cations and anions that can significantly change the physiochemical properties of the ions generated. So these have very outstanding properties which include the negligible vapor pressure, non-flammability, high thermal and chemical solubility, regeneration and reutilization. Due to this negligible vapor pressure of the IS, there are the minimal losses and the contamination during the CO2 capture is very less, so which causes the very less energy consumption, and also the equipment investment is very low in this case. We are working particularly on the binary and the ternary mixture, because if we talk about binary liquid mixture, these are always preferred over the single component liquid systems in various systems. So we are trying to develop various mixtures which can be used for the carbon capture. The main objective of our study is to comparatively analyze the ionic liquid mixtures and to study the effect of various thermodynamic properties on the carbon capture. Initially, in some of the studies, we have found that the fluorinated compounds, the compounds which are having anions with the fluorinated anions, are favored for the carbon capture. But then we have studies where the tetracyanoborate anion was favored with the imidazolium cation. Imidazolium is one of the basic cation that is used in the ionic liquid. Also, with the tetracyanoborate anion, we have the higher solubility, low viscosity, and less ecotoxicity. Then there were further studies where the anions were compared for their carbon capture. According to these studies, the tris-pentafluoroethyl trifluorophosphate was found to have the highest value as anion for the carbon capture. In the further studies by Chanuri and Gardner especially, in which they have studied about the protic ionic liquids, they have concluded that the variation in alkyl chain length led to deviation in other derived properties, such as
So,
the
Pooja, can you please conclude because we are very close to the closing session. So,
okay, sir.
Conclude,
Okay,
yeah.
sir. So concludingly, I can say that the selection of proper ionic liquid for carbon capture can be done by analyzing its thermodynamic properties. For better CO2 solubility, we can have the increase in the alkyl chain length. So the cation having the alkyl chain, that should be having greater number of the carbons. So anion should have higher molar volumes, and the binding energy for the cation and anion should be low. Viscosity values should be low. For the mixtures, we should have the positive deviation from the ideality. So mixture with the positive excess volume can be used for the carbon capture for the better. And moreover, temperature, pressure, and water content can be used at the optimum conditions to get the maximum value of the CO2 solubility. That's all from my side.
All right. So thank you, Pooja. So we can go to the next slide shortly. Next slide. Next slide. Yes.
Hello, good afternoon, sir.
Okay. Okay. Please go ahead.
Okay, sir. Thank you, sir.
Okay.
There is growing demand of fossil fuels in various life activities, including transportation, energy production, industrial operation, and household consumption. Constant concern over rapidly increased crude oil prices and their unpleasant effects have permitted researchers to pursue for optional fuel, which aggregate harmonious link with sustainable development, energy conservation, and environment preservation. Global modernization and expanding population growth is presently confronted with increases of fossil fuel depletion and environmental degradation. In last couple of decades, biodiesel has emerged as biorenewable liquid to control both global warming and air pollution. It is non-petroleum-based diesel fuel considered long-chain alkyl ester and manufactured domestically from feedstocks such as plant tissue, oil seed, and microorganism through transesterification reaction in the presence of catalyst. Although chemical catalytic method offer the merits of tolerating various raw material, high production efficiency, and easiest industrial scale up, but also suffer from some disadvantages such as zero corrosiveness of acid-base catalyst, low safety, high consumption, difficult recovery of catalyst, preparation of heterogeneous catalyst, and unstable activity. Recently, ionic liquid have attracted tremendous scientific and industrial interest due to its characteristic properties like negligible vapor pressure, low flammability, good thermal and chemical stability, broad liquidage, wide range of solubility, and high electrical conductivity. ISL fused have a melting point below 100 degrees Celsius. Their properties can be designed by smart combination of cation and to suit a particular task. Objective to search effective and stable ILs and catalyst for efficient biodiesel production from different feedstocks. To explore the effect of molar ratio of methanol to oil catalyst dose
Okay.
reaction
Okay. Pooja, please conclude because we are very close to the final session. So please conclude and we can pick the next speaker.
Okay, sir. Okay, sir.
Okay.
Conclusion.
Yeah.
The hydrophobic ionic liquids prove environmental friendly catalyst compared to conventional solvents, as has ability to produce low cost biodiesel from low cost feedstocks such as waste cooking oil. The catalytic performance of IS depend on several factors like nature of cationic and anionic moieties, length of alkyl chain, conductivity of fire, reactant molar ratio, reaction temperature, catalyst dose, reaction time, and steering speeds. Thanks. Thank
Okay,
you, sir.
thank you very much. Thank you very much.
Okay, sir.
Okay, so Monica Sharma.
Yes, yes, sir.
Okay, please. Yeah, please.
Yes, sir.
Please start. Yeah.
Good afternoon to all of you. And today topic is the role of organocatalysis in green synthetic chemistry. So first of all, abstract. Main aim of the making this article is the advancement in the science and technology in the field of organocatalysis for achieving the goal of green environment, that further achieving the objective of good health. So organocatalysis is another greener option as compared to the metal-based catalysis. So trend of organocatalysis has been increasing due to the use of variety of spot materials, inorganic, organic, ionic liquids that play a great role in the green chemistry. Because spotted catalyst can be easily recyclable and reused without affecting the catalytic activity. Different methods are used for heterogenizing it. So next one is the introduction. As the name suggests, organocatalyst, organic material. Organic means made up of the non-metals like the carbon, hydrogen, sulfur, phosphorus, etc. And catalysis is working of the catalyst for increasing the rate of reaction and decreasing the undesirable rate. So the main aim of growing this field is novelty of the concept and is highly efficient and easily recyclable. Next one is methods. Different methods used for heterogenizing it, that is impregnation and ship in a bottle method and grafting, in which grafting is the most widely used because in this catalyst is directly linked to the spot material or catalyst is linked through the linker. Next is a type of immobilized organocatalyst. Insoluble catalyst characterization में difficulty cause करती है. And next one is soluble polymer spots, that is a soluble and it is a easily recognized by using the solution state spectroscopy. Next one is silica spotted organocatalysis. Silica has a good diffusibility, so it is the most widely used as a spot material. Next one is a magnetic nanoparticle. It is the most widely used because of the good property in which the catalyst is very easily recyclable. Next one is advantages, applicability, apply at the larger as well as a smaller scale. Available at the low prices. Recovery is quite easy when immobilization technology is used. Next one is reaction conditions, mild reaction condition that is not required a higher temperature. And then next one is a fulfill the requirement of green chemistry, that is a high atom economic and the lesser the chances of hazardous gases production. And sensitivity is insensitive to moisture and air, so handling is quite easy. Next one is examples, organocatalysis. First of all, modified Macmillan amidazoline 4-on. This is an organocatalysis and it is spotted with the magnetic nanoparticle. And it is mainly used in the reactions like the cycloaddition and Friedel-Crafts alkylation reactions. Advantages, that is, it is a no leaching like the polystyrene spot materials. Next one is a tryptophan. Next one is a dialkyl aminopyridine. It is also used as an organocatalyst and it is immobilized. This is a best example in which the magnetic nanoparticles are immobilized with the silica, because nowadays combination is more frequently used as compared to the alone like silica or magnetic nanoparticles. So it is widely used and recyclable up it to the 10 times without the loss of activity. Next one is L-glutamine, that is it is a silica magnetic nanoparticle spotted organocatalyst and it is mainly used in the synthesis of spiroxoandol derivatives and it is also used as a 6 cycles. Next one is diameric cinchona alkaloid. Best example is a high stability of the catalyst more than the 5300 hours. Next one is a conclusion. The main aim of writing this article is it is an alternative to metal-based catalysis and is fulfill all the requirements of green chemistry principles. There is a green chemistry, 12 principles are present, and to meet the need for energy efficient, atom economic, pollution-free environment and avoid the contamination of pharmaceutical product due to the absence of metal. And organocatalysis is also used to yield the 100% product, 100% initial selectivity, and higher purity. And among all this, magnetic nanoparticle is the best spot material for immobilizing the organocatalyst, and is nowadays it is very commonly in the combination form magnetic nanoparticle and silica. So I would like to thank my teacher and my parents who helped a lot. Thanks.
Yes, any questions, please? Okay, thank you, Monica. Yes.
Thank you, sir.
Okay, Jana Saab.
Thank you very much.
Professor, I am Maheshwaran from Gujarat. Where is my poster? Sir, already I sent to you 2 days back, sir. Yes, sir.
So you want to present now?
Yes, sir. Yes, sir. Yes, sir.
Okay, you can present it.
Yes, sir. Professor, 2 days back I sent you. Yes, sir.
Oh, so I can give you the access, so you can share that.
Ah, yes, sir. Sure.
Okay, I am giving.
I share you, sir. Yes, sir.
Okay.
Please give the access, sir.
All right.
Yes, sir.
Now
yes,
you
sir.
share.
Yes, sir. Yeah, definitely, sir.
Yeah, Maheshwaran, just try to complete within 3 to 4 minutes.
Yes.
Yes, sir. Yes, sir.
Just make it fast.
Yeah. 1 or 2 minutes, sir. Yes, sir. Yeah, sure. Sorry, no, sir. Sir, are you visible my poster?
Yes. Please, yeah, go ahead.
Yeah, my title is Relaxation and Transport Properties, Proton Conducting in Nanocomposite Polymer Gel Electrolyte. Introduction, myself Maheshwaran from Gujarat, Baroda University, under the guidance of T.K. Kanchan. Introduction, the gel polymer electrolyte materials using the PEO plus MgTF with proton salt. That's why my experimental work I mentioned here. Salt plus SiO2 nanofiller. This is the freestanding film. Characterization have done the DSC and the electrochemical analysis Scolaratum impedance spectroscopy 1260 and the CV cyclic voltammetry with the help of the CH instrument. First of all, I have mentioned the tan delta. This is a relaxation peak, and another one is the modulus. We will calculate that relaxation phenomena. At the third, the electrical conductivity sigma is the TC conductivity. What is the few T in the low concentration give the Arrhenius behavior, and the higher concentration give the VTF behavior. So I mentioned the formula also, and constant temperature with the dielectric loss also. Last, that cyclic voltammetry and transport study, both cycle is there. Cyclic voltammetry, the reduction and oxidation. This is the MgMg cation cyclic voltammetry. The total transport number around 0.99%, and the cation transport give the 0.32 volt. It is confirmed the Mg2 plus ion conduction in this system, and the proton also, but the maximum conductivity 5.5 into 10 to the power minus 4. It is suitable for the magnesium rechargeable battery. References and acknowledgement. Thank you, sir. Thank you, sir.
Thank you very much, because you make it very fast. I really appreciate that. And now please stop the screen sharing. Thank you, Mahesh.
Yeah. Stop. Yes, sir. Yes, sir. Thank you, sir.
Thank you very much.
Sir.
Yeah.
Thank you.
Yes, Jana sir.
Okay, so now we are close to the closing session, and I am grateful to all the speakers and all the presenters, and particularly Professor K. Ramakrishna, and and so yeah, so after that I want to hand over this session to the next session to HOD. So please.
Yeah.
Okay, thank you, Dr. Atanujana. I welcome all the participants, resource persons, Professor Ramakrishna Garu, and then the principal of GITAM School of Science, Hyderabad, Professor Ramarao Garu, principal of GITAM School of Science, Bengaluru, Dr. Atul Kumar Garu, and then the Dean of Science, Subramanyam Garu, and my colleagues, the co-convener of the program, Dr. Atanujana, and the coordinators, Dr. Ratnamala and Dr. Nagaraju and other colleagues. So I am so thankful for the help that we received from both our own colleagues as well as the presenters for successful completion of that. So before we are moving to the last session, that is a validatory session. The validatory session, this one goes for only 10 to 15 minutes. So first of all, the validatory session will be taken over by Dr. K. Nagaraju. He is going to take the feedback from the participants, and then he introduces the dignitaries, and then there will be message by Professor Subramanyam Garu, Professor Ramarao Garu, Professor Ratnamala, and Professor Atul Kumar. So and the program will be ended with the national anthem. Now the session is over to Dr. Nagaraju. Nagaraju sir, please.
Thank you. Thank you, Prof. Venkatnath. Good afternoon once again. Good afternoon to all. It is a great privilege to be being here. Today we are in a closing phase in this event. I take this opportunity to my special thanks to Prof. Ramarao Garu, GITAM Science College Principal, Hyderabad, and also thankful to Prof. Venkatnath, HOD of Department of Chemistry, GITAM Bengaluru. And I would like to welcome Prof. Subramanian, Dean of Science, GITAM. Maybe he's not joining yet. He will join like a little bit late, 5 minutes. Maybe some technical reason or something. And also welcome to Prof. Ramarao Garu, GITAM Science College Principal, Hyderabad. It has been our privilege, pleasure to host all the participants of the 3 days International Conference at GITAM Bengaluru. The participants were very enthusiastic. I am thankful to all the participants for attending to this conference. We had 3 days of the lovely discussions on these different aspects of subjects like biomedical applications, material research, biofilters, and nanosensors, etc. We had delegates from the various countries, like including Japan, Kenya, South Africa, Denmark, and our home country, India. I'm very glad I have been received a huge number of abstracts. It's like around 190, out of which 60 delegates presented their research credentials in terms of the oral presentation, and another 24 poster presentations. I believe and I am sure that the participants must have benefited by attending this conference, and they have learned some scientific knowledge about all the delegates and all the plenary speakers. I thankful all plenary speakers and the delegates for their enthusiastic participation in this conference. My thanks also goes to support received from the chairpersons from all the sessions, and also faculty and staff members of the Department of the Chemistry and Bangalore GITAM. And I especially tell my experience in this, especially in this conference. When I was met with head of the department, Prof. Venkatnath, he discussed with me about this event. That time I was felt a little bit nervous because of this international conference, and how would I manage to bring all the international speakers in the one platform? But it is not a easy to task to bring them all in the one platform. I thank my colleague Dr. Atanujana, Associate Professor. With his help, finally we were managed to brought them, and we are organized successfully. We made them event successfully, great success for with the all the help. And I thank also in the part of the event Dr. Ratnamala Madam, coordinator of this conference, and also thank to convener of the event, Prof. Venkatnath. Thank you all the people who have given their precious time in the organizing 3 days international workshop. And welcome to, and I hand out this session to today's delegates, Prof. Ramarao Garu, Principal of Hyderabad Campus, School of Science. Prof. Ramarao Garu.
Yeah, good evening, everybody. Thank you.
Yeah, good afternoon.
Thank you for giving me this opportunity. I compliment and congratulate the organizers for having taken this development program. In spite of the COVID, I can see that the number of people who have attended this program and presented data. See that COVID has not come in the way, and science and technology has taken care of COVID, prevent people to come. This topic is very relevant text we are going through to make a situation. But I still wonder where are disease care? Because science and technology, all innovations and that are happening in critical industries, they are taking care of the disease better than the health care. Because for healthcare, we have to depend more on our traditions and culture and right from the beginning, right from our ancestors, we have to learn many things how to take care of our health. Science and technology, we are depending on more because the population is increasing, attitudes are changing, people are coming out with new diseases, new medicines, new pharmaceuticals. Pharmaceuticals are growing only because of new diseases that are coming up. And this is how science and technology is growing because of the diseases are growing. About environment, actually, science and technology, I don't know how much it is helping to environment. In fact, we see more of a deterioration in the quality of environment that are happening now in spite of science and technology growing. But, we could not find many replacements like sand. Sand is being taken and the rivers are flowing. Water levels in the rivers are going down and down. Sea levels are rising and water in the rivers, they are not flowing into the sea. Quality of water in the rivers, they are becoming salty, being used for any domestic purpose. Even hills are getting destroyed now because sand is not there. Hills are getting destroyed and science and technology is not coming in the way to help the people. Nature, we are praying against the nature. COVID is one such example how nature can correct itself. Troubling people to tell the people that how nature can be kind of teaching a lesson to the people. They don't care of they don't take care of the nature. Energy is one issue because population is increasing, energy demands are going up. They are not able to come up with alternative to fossil fuels like coal and oil, gas and coal. But still we are allowing people to go dig more coal, play with Mother Nature, Mother Earth, take out all the coal what is left behind. Future, I think only our grandchildren will be seeing a small piece of coal in the museum. Once upon a time, there used to be a coal like this, a black piece. Situation is coming to that extent. I don't see in the near future anything will come up as long as coal is available, oil is available. Yes. Only when nothing is available, then people will look for an alternative. The way it is expected to grow, solar and wind is not going to that extent. Youngsters, because the future of the nation or future of the globe is in their hands, they have to come up with it. Aged people like us, we have no solution. So that the present problems, because they have to take care of the nature, they have to take care of the Mother Earth. It is very timely to think about organizing this kind of program, especially in the context of COVID. Compliment and congratulate the organizers once again. I thank my colleagues at Bangalore. In fact, they are doing wonderfully well with conducting very, very good programs, very relevant and apt programs, depending on the situation. Wish them success already they have achieved, to continue to achieve. Thank you very much.
Thank you, Professor Ramarasa. Now, I will request you participants, if anybody have the feedback from this event. I request you all the participants, if anyone giving the feedback of this event for the past 3 days, for all the sessions, session 1, session 2, session 3, 4, 5, and 6. You should unmute your mic and you can speak if you want.
Can I speak, sir?
Yes, madam, you can speak, madam. You can introduce yourself and speak.
Good afternoon to everyone. First of all, I want to congratulate the organizing team of GITAM Bangalore campus. Actually, this seminar is very useful and I feel it's a unique one because all these days, during these pandemic times, we used to attend attending, that means just appearing for the conferences. Unlike that, now you have showed the way that even in online also you can present your paper. This is a very unique idea, and for this I congratulate the organizers and the GITAM University. Thank you very much for giving us this opportunity. Thank you, sir.
Thank you, Dr. Sunita.
Yes, sir. Thank you, sir.
If anybody have giving the feedback.
Actually, excuse me, sir. One
Yeah,
moment.
tell me.
Actually, it is a purely science one, but I tried to present my legal views also in this because law is applicable to every field, but I couldn't.
Yeah, we are accepting, Dr. Sunita. We are organizing another one in the next couple of months. I think I hope to you receive my like a browser and all the things. I think we are accepting your abstract. And
thank you very much, sir, for giving.
I think we hope to. We are requesting you all for the future support and cooperation with us.
Sure,
we need
sir.
for your cooperation also. If anybody have that other participants for the for this event,
thank you very much.
Thank you, madam. Requesting you all, anyone? Okay. Okay, now welcome to Prof. Subramani Garu, Dean of Science, GITAM, Visakhapatnam. Now I will invite him to share about this event.
Thank you very much. I must say, sorry, I was not able to be present at the inaugural or during the sessions, but I have been following it closely, and the feedback looks to be excellent. And Professor Ramarao Garu said what is really important. I think the Bangalore team, whether it is Bangalore, Visakhapatnam, or Hyderabad, GITAM is GITAM. The International Conference on Advances in Science and Technology for Betterment of Health, Environment, and Energy. And if you are accepting even the law and everything, that's very wonderful. There is nothing uncovered in this. What I would like to ask you is, in the pandemic, before going into that, I must really thank the resource persons, Ramakrishna Rao Garu, Ishida, and Olengo, and Antus, Methi, and Bhavrang. All this team is possible because of Venkatanath, Atanu Jana, Ratnamala, and Nagaraju Kiran. People have worked so hard for this. I mean, hard work, cooperation, coherence is the mantra for success. Every one of us knows. What is important is, if say 100 people died of COVID, you read in the newspaper, that is a news. Suppose if my close relative is dead because of COVID, that's a calamity. If my family members die because of COVID, then I see COVID is too much. And if I throw my garbage onto the main road, I say my house is clean. And if the garbage is not cleaned by the municipality, you ask the municipality one question, I pay my taxes, I have not cleaned it. And if the power is not there, take a summer morning, summer afternoon, if your air conditioner is not working, you start blaming the electricity department. So to say, the health, the environment and the energy are given to us by nature and we don't care about it. But when we don't have it, then you start suddenly realizing it what's happening. So an awareness among all of us and a work cooperative to all of us must be done in order to, I mean, I'm not a patriot. I never say make India great. No. I would like to say make yourself great, make yourself self-sufficient, make sure your society is self-sufficient. That's all. I can't go to Delhi and I cannot preach saying that you must give energy and all. There are policy decisions. But this awareness has to be created among us in a nice fashion. For example, take the fact every day morning you go to the washroom, open the tap, you get water. You don't care. Suddenly one fine morning, you don't get water in the washroom. Then you ask a question. Hey, why am I not getting it? Whom should I ask? That day you realize there is one person who is responsible for getting water into your washroom. Then only you remember it, otherwise not. So to say, these are all the silent workers. But even for the silent workers, you have to remember that without them, we are nowhere. Without the environment, we are nowhere. Okay, today the world is going towards zero energy and zero carbon. Energy balance, zero carbon are the two things. America has already implemented it. Europe is doing it, and we are nowhere nearby. Why? Because we always feel selfish about all the three factors: health, environment, and energy. And you don't really care if a private hospital is throwing the garbage of the hospital waste into the dustbin. You take it normal. You don't really shout at that person. But what you do not realize is a bio-waste is more dangerous than a bomb. A bomb will kill you. Bio-waste will not kill you so easily. So these are the factors one should be aware of. How do you make aware of it? You don't until and unless somebody points to you. That's what exactly GITAM is trying to do, which is an awareness from an academia, which is a responsibility of the academia. They took the trouble, they made you aware, and they are putting a lot of effort. For that, I must really congratulate my team. And I could see about 100, 120 participants are there. And I could also hear how the feedback is so excellent. I'm so happy because after working so hard, they put a lot of energy, and you are the environment. And these two put together, we get a healthy conference. This is a success. Okay. So I'm so happy. And when you are going back, pause a little bit today evening, ask one question. What did I learn from this conference? In particular, if you are really conscious of, ask a question when you go to bed. What did I learn today? What did I do to the society? Did I hurt anybody with my words, my actions? If these three questions, if you get a good positive answer, then your day is done. Okay, so I'm really thankful for the organizers to give me this opportunity to address you and tell my concerns. I hope we will have many more meetings, and I wish you all the best. Carry the memories, execute whatever a little we can. Remember GITAM. GITAM stands for quality. GITAM stands for harmony, and GITAM stands for concern. This is all what I would like to say. Thank you very much.
Thanks, Professor Subramanian Garu. Thank you for your valuable words to all the participants and me too, and all of my colleagues also.
Feedback from any other members? Okay, Nagaraj.
Yeah, once again, I requesting all feedbacks, anybody. please unmute yourself and speak something about the regarding this conference.
Yes, sir.
Yeah. Okay.
I am Dr. Dilip Kumar Mishra from Odisha. Attending such a beautiful webinar, I am very impressed and learn different knowledges and techniques from the various speakers, lectures, and from the PPT. So it's a good time to learn in the COVID periods. So another request for GITAM from my sides, since I am working with a college having no instrumental facilities, but I have near about 56 students every year passing out 12th class. They are interested to study the engineering courses. I am also referring various organizations to Andhra Pradesh, Bangalore, like this. But if this organization previously contacted to me and give a chance to my student to visit their labs, how they are carrying the research work particularly, then I will be obliged and I will be grateful for you.
Thank you, Dilip Kumar Mishra, sir. We are very happy that you want to visit our institution along with your kids. You are always welcome. We'll be in contact with you, and let us have one special trip of your students of our organization, sir.
Thank you, sir.
And any other persons? Dr. S. Idris from Malaysia, you want to share something? Dr. S. Idris. Okay. Next, I requesting Prof. Venkatnath Garu, shall I proceed to vote of thanks?
Yeah, please.
Yeah, I requesting to my colleague and the coordinator of this event, Dr. Ratnamala.
Okay, sir. Thank you.
Yeah,
Thank you,
you can
Dr.
start.
Nagaraju. Thank you, Dr. Nagaraju.
Okay.
Hello, everyone. I am Dr. A. Ratnamala, Assistant Professor, Department of Chemistry, GITAM School of Science, GITAM deemed to be University, Bengaluru campus. My pleasant greetings to one and all. I deem it my privilege to propose the vote of thanks on the occasion of International E-Conference on Advances in Science and Technology for the betterment of health, environment, and energy, held from 1st to 3rd December 2020. This event is a huge success and organizers receive laurels from the participants because of the eminent speakers like Dr. S. Ramakrishna Rao, former Vice Chancellor, Krishna University, Machilipatnam, Dr. Masatoshi Ishida, Graduate School of Engineering, Center for Molecular Systems, Kyushu University, Fukuoka, Japan, and Dr. Moses, Director of Research, Dedan Kimathi University of Technology, Private Bag, Kenya, Dr. Edith Anthons, Department of Chemistry, University of Western Cape, South Africa, and Prasenjit Moiety from School of Engineering and Technology, National Forensic Science University, Gandhinagar, and Dr. Stephen Boring, University of Southern Denmark, and in addition, the presentations of the researchers from different countries like USA, UK, Japan, Denmark, Canada, Saudi Arabia, South Africa, Malaysia, Thailand, Nigeria, Egypt, South Korea, China, Kenya, Mexico, Russia made the conference true international. And reflecting a successful e-conference from GITAM Bengaluru campus. On this occasion, we would like to place on record my sincere appreciation and excellent contribution made by all the speakers for sparing their valuable time and enlighten the participants by sharing their research expertise. At the outset, I would like to express my gratitude to Shri M. Bharat, President GITAM, and Professor K. Ramakrishna Rao, Chancellor GITAM, for their unconditional support. I would like to express my sincere obligation to Professor K. Sivaram Krishna, Vice Chancellor GITAM, and Dr. Gunashekaran, Registrar GITAM, for giving us inspiration to conduct such event continuously. I wish to record our heartfelt thanks to Professor D.S. Rao, Pro Vice Chancellor, GITAM Bengaluru, and Professor Atul Kumar, Principal, School of Sciences, for their constant support and guidance. We are extremely grateful to Mr. Vamsi Danta, Director, Admissions and Administration, for being a pillar for support our efforts. The smooth conduct of all the technical sessions were possible only due to the eminent chairs of the sessions. I thank all the chair sessions or chairpersons for each and every day session. I would like to express my appreciation to Professor R. Venkatnath, convener, and Dr. Atanu Jana, co-convener, and Dr. Nagaraju, coordinator, Department of Chemistry, GITAM School of Science, GITAM Bengaluru campus, for successfully organizing and scaling up the event to new heights. In spite of the lockdown period and pandemic situation, we are able to successfully organize the program due to the relentless efforts of the CATS department, as well as the faculty members and supporting staff of chemistry and other departments. I profusely thank everyone for their efforts. Our special thanks to print and electronic media for wide coverage of the program. We are thankful to the participants for their attentive participation and enthusiasm expressed during the interaction with the subject experts in the technical sessions. Lastly, I thank all the heads of the departments, faculty members, staff who have witnessed this event and extended their cooperation. Thank you once again to all, and we look forward to an extremely productive and encouraging year ahead. Thank you one and all.
We are extremely thankful to Professor Subramanian Garu, the Dean of Science, who spared his valuable time. Actually, Sir was engaged in some other meeting. We disturbed them a number of times, and Sir has taken an excuse from the higher officials, and Sir has given his blessings to all of us. Thank you, Subramanian Garu. Thank you very much. I think Dr. Arnab Kanti Iri wants to speak something. They can unmute if they want to speak.
No, it's okay.
Please go ahead, sir. Please conclude within a few seconds.
Yeah, actually, it's a very nice session, and I gain much knowledge. And I congratulate to GITAM Bengaluru for this nice conference. And I always be with GITAM Bengaluru in any kind of means collaboration work if it is possible, because I am from actually material chemist, so I am always looking for such university and always look for such a good collaboration for the purpose. So thank you for giving me that opportunity.
Well, thank you, Dr. Arnab. Okay, we are very happy to announce that soon we are going to conduct one more international e-conference on synergetic research developments in chemical, biological, and environmental sciences in 4th week of February 2021. Earlier, we used to conduct this one physically, the national conference. Because of this pandemic, we are going this one as a e-conference. Now, I would like to request Nagaraju to go ahead for the closing session. Janagamana.
Bye.
Jai Hind.
Thank you, Dr. Nagaraju. Okay,
Thank you.
it's a formal announcement. By December 15th, all the presenters and participants are going to receive their certificates by email. As far as the best oral presentation and the best poster presentations are concerned, already the chairs of the sessions, they have given their information. They have to be consolidated by the concerned coordinators, device coordinators. They will come to a conclusion, and then we hope that the same certificates will be distributed and announced by 15th December. So thank you very much. By 15th December, everyone is going to receive their certificates. Whoever participated, whoever presented, whoever is going to win the best oral and poster presentations. So once again, I am so thankful to the GITAM, my colleagues, my officials, Ramarao Garu, and then Subramanian Garu, Atul Kumar Garu, DS Rao Garu, and the President Bharat Garu, and each and everyone. So with this, formally the program is concluded. However, if any participant wants to have some more information, they can unmute themselves and they can pose the questions.
I think no more questions, sir. I think we'll go ahead.
Let us wait for a few minutes. If anyone is having any question, let's wait. Some members may hesitate to pose the questions in presence of others. So the participants, if they have any query, they can email us. Our email IDs are with you, and the contact numbers are also available with you. If you have any query regarding this conference, you can either call or you can email us. Thank you very much.
Yeah, thank you once again. I am also thank you to all. I think we'll close the session, sir. Are you okay with that?
Yes, as there are no other questions, we can close the session.
I think no more quiz, I think so. They all are saying thank you so much, thank you so much. We'll close the session. Jana sir, you should close the session.